Predictive Analytics, one of the most important modules that is a prerequisite in your data AI journey. Be it data analytics, data science, or AI engineering. This is Satyajit Pattnaik welcoming you all to my channel, which is famous for such end-to-end tutorials around data analytics, data science, and AI. And welcome you back to another beautiful end-to-end series on predictive analytics. This is going to be a 5 hours one-stop solution for predictive analytics in case you are getting started with your journey in data analytics, into data science, or even AI engineering. Predictive analytics is one of the most important modules, and in this video we are going to talk about various aspects of predictive analytics. If you want the codes used in this particular tutorial, just write down PA, and at 100 likes and 50 comments we will be sending you all the codes used in this tutorial. Apart from this, if you have a requirement on any such topic, be it anything around data analytics, data science, AI, agentic AI, let me know what should be our next end-to-end tutorial, and we will also come up with that. Without further ado, let's get started. Enjoy this video. Hi, welcome to this module on predictive analytics. Before getting into predictive analytics, let's try to understand the different types of analytics. Analytics are majorly of four types. One is descriptive analytics, one is diagnostic analytics, one is prescriptive analytics, and one is predictive analytics. And all this combined together to form the analytics domain. Descriptive is basically what happened. If you have a data, if you are able to find out what has happened, what are the people that are churning, what are the possible people that are marked as fraudulent, what are the characteristics. So the what part is the descriptive analytics. Diagnostic is you're diagnosing the problem. What could be the problem? Why it happened? If 20% of the customers have left the company, why they have left? Prescriptive is nothing but how can we make it happen? The how part. And predictive is what will happen. That means the future part. Now let's say you have a data set of customers data where 20% is your churn rate. That means 20% of your customers are churning on a monthly basis or on a yearly basis. The what will happen part basically means if by taking the data you are able to create a predictive model, the model will be able to understand the pattern, and for a new customer it will be able to predict. That is basically a predictive analytics part. So going forward, let's try to understand more about predictive analytics. Predictive analytics is the branch of the advanced analytics which is used to make predictions about unknown future events. Predictive analytics uses many techniques using data mining, statistics, modeling, machine learning, AI to analyze current data to make predictions. So in simple layman's term, predictive analytics is that field of analytics, is that branch of analytics which is used to make predictions. Now let's say you have data, customers data, and 20% customers have joined, 80% customers are active. If you are able to create a model, let's consider it as just a model. The model will be able to read and understand the pattern, understand the behavior, and will be able to predict the future. That means for a given new customer, will it be able to predict it as active or churned? What will be the customer after 6 months? Will he stay in the company or will he leave the company? That is what the predictive analytics part is. Another use case of predictive analytics is, let's say you are analyzing your country's temperature data. Let's say you are from Malaysia and you are analyzing your country's temperature data. So you have columns like date, temperature, rainfall, precipitation, and so on. You need to predict temperature. So you have existing 24 months of data. Let's say starting from 2021 till end of 2022. If somebody asks you, can you do a prediction for the entire January month 2023? The answer is yes, it is quite possible. And how it is possible? By using predictive analytics. Further inside predictive analytics, there are multiple other sub branches or sub modules which we will be covering in the future. The sub modules includes classification, regression, sometimes series analysis, and so on. But I hope you got a fair amount of idea about the predictive analytics parts. It's simply nothing but a data is available. When you are analyzing the data, that's the descriptive part. When you analyze the data and make a model which is able to understand the data, understand the pattern, understand the behavior, and is able to predict something for the future, or predict something for a record that is not a part of your original data set. That is your predictive analytics part. That is your predictive model. Let's talk about the predictive analytics process. It all starts with data. Data is the core. Without data, nothing is possible. Be it your predictive analytics, your descriptive analytics, or be it anything. Data is mandatory. Without data, nothing is possible. Data needed for predictive analytics is usually a mixture of historical data and real time data. Historical data is that kind of data that you have already been capturing from the past couple of months, couple of years, or couple of weeks. And real time data is real time. Now, for example, you are analyzing, let's say, temperature. You are analyzing the temperature data of a particular area. Let's say Tokyo. I'm not pretty sure about the temperature in Tokyo right now, but let's assume from the last 5 days or 10 days or 20 days, the temperature is somewhere around uh, 10-15 degrees Celsius. Let's say 10 degrees, then 11 degrees, then 12 degrees, then 13 degrees, then 11 degrees, and so on. So from Jan 21 till December 2022, you have the historical data. You create a model on January 1st, 2023. Now, right now, your model is using historical data, which is from January 2021 till December 2022, which is almost 2 years data. But the model after January 1st, when it will read the January 2nd data, obviously it is using the historical data and also the real time existing data. Or else a real time example could be stock market. Everybody knows that stock market values changes every minute or every 5 minutes. That means when you are building some models, the model is working on a real time data, a real time streaming data, right? So that is basically real time data, and historical data is the data that we have been capturing from the past couple of years. Reporting and analysis. Reporting includes creating, configuring, consolidating, organizing, formatting, and summarizing. Detailed examination of the elements or structure of something. Monitoring. Data monitoring is a business practice in which critical business data is routinely checked against quality control rules. And then we have predictive analytics, which is the branch of advanced analytics that makes predictions about future outcomes using historical data combined with statistical modeling, data mining techniques, and machine learning. Now, this particular screen will help you out in understanding more about the predictive modeling part. Now, before talking about all these points, let me just quickly refresh your memory on what we studied when we were talking about how to build an end-to-end data analytics pipeline. I hope everybody remembers it all starts with business understanding. Then comes data understanding. Then comes data collection. After your data is collected, then comes your data preparation. After your data preparation is done, which is basically clean data, then you perform EDA, which is your descriptive part. After EDA is done, your next step is usually to create a model. And then once your model is done, you have to deploy it. Basically, a data analytics solution is limited here, but sometimes when you are solving a data science problem or a predictive modeling problem, in that case, you can also use these two steps. Predictive modeling or predictive analytics, however, is a part of data analytics, but in the industry, we treat predictive analytics as a part of data science because predictive analytics or predictive modeling is simply nothing but machine learning. Now, when it comes to model, now model is just one step. Inside the model, there are further sub steps, and they are creating a model, testing the model, validating the model, and evaluating the model. And once everything is done, then we have to deploy the model. What do you mean by creating the model? Creating the model simply means you have an existing data, 10,000 records. Some customers are churned, let's say 2,000 are churned, which is 20%. Rest 8,000 are active, which is 80%. And using that data, you create a model which is able to read these records, understand which customer is churned, which is active, and so on. And it has created the model. How do you test the model? Normally, while testing the model, it is always recommended to create a model on training data. Now, what do you mean by training data? Imagine your entire data set is of 10,000 records. If you use the entire data set to create a model, your model will be trained on 10,000 records. That means the model understands and knows all the patterns inside the 10,000 records. How will the model be tested? The model cannot be tested if it is trained on the entire population. But instead of 10,000 records, if you randomly split them into two books or two chunks, let's say 7.5k in one group and 2.5k in another group. Now this 7.5k could have again 80-20 ratio of churned and active customers, same with this. Okay. Now what happens here is we treat this as training data and treat this as testing data. Now this training data goes and the model is created using 7.5 thousand records or 7,500 records. And then the model is tested on 2,500 records. Now for these 2,500 records, we already know which of them are active, which of them are churned. But here what happens is the model predicts which records are active, which records are churned. Then what we do is we compare the predicted values with the actual test values. And this is basically the validating step. And then we evaluate the model whether the model is fine or not. In real-time scenarios, we create multiple models. So in real-time scenario, how it happens, probably I'll take another example for better understanding. I'll take a similar example, but I'll take a similar example, but the use case will be different so that you can understand what's going on. Let's say I'm talking about fraud detection. Fraud detection. I have a data set of 10,000 records. Out of them, 9,000 records are not fraud and 1,000 records are fraud. So what is the fraud ratio? 10 is to 90 or 1 is to 9. So 10% of my records are fraudulent records. The very first step that we do in machine learning or predictive analytics is we divide the data set into training and test. Now the division into training and test, the split into training and test happens randomly. There is a concept, there is a library that we import, sklearn library. Inside sklearn library, there is a method called as train, test, split. And then we split the records. Usually we split it into 75% and 25%. Sometimes we also do 80-20. There is no thumb rule for this. So what do you mean by 75% records? That means 7,500 records are here and 2,500 records are here. So out of 75,000 records, how many are fraudulent? You can equally distribute them based on this or randomly distribute them. Again, that is depending on your sampling technique. Let's assume that we are doing a stratified sampling. I hope everybody knows about stratified sampling. We are doing a stratified sampling, and out of the 7,500 records, 75 are fraudulent. 1,000, 9,000, 10. 10%. 10% is 750. 750 are fraudulent, and rest 6,750 are not fraudulent. And out of this 2,500, 250 are fraudulent and rest 2,250 are not fraudulent. Now what happens is from this 7,500 records, we kind of create models. We create multiple models. Model 1, model 2, model n, dot dot dot. That means multiple models we create. And all the models are created on training data. I will mark it as TR and TE. All the models are created on training data. Then what happens? Then models are tested on testing data. Then we do some predictions, predictions, predictions. Now there are 2,500 testing records. So 2,500 predictions will be done. Now I cannot show you by taking 2,500 records. Imagine there are only 5 records as part of testing data. Out of those 5 records, the first one is fraudulent, second is not fraudulent, not fraudulent, not fraudulent, and not fraudulent. Imagine. Now this model has predicted this as fraudulent, this as fraudulent, and others are not fraudulent. The second model has predicted this as fraudulent, not fraudulent, not fraudulent, not fraudulent, fraudulent. And the nth record and the nth model has predicted this as fraudulent, not fraudulent, not fraudulent, not fraudulent, not fraudulent. What is the error here? There is one error here. So the accuracy is 80%. What is the error here? The error here is here. So accuracy is 80%. Here there are no errors. So accuracy is 100%. Now I'm just taking an example with 5 records. Imagine this thing happens with 2,500 records, and finally we get accuracy and different other metrics from each model. Let's say this model is giving me 81% accuracy, this is giving 82 dot dot dot, and this is giving you 78%. Then what we do is we finalize one of them models that this is the best model. Then what we do is we go ahead, and again there are some further steps in predictive analytics which includes feature engineering, hyperparameter optimization, and then we fine tune the model to boost the accuracy. As a data scientist or as a data analyst, our first focus is to boost this. If you are able to get a 90% accuracy on your testing data, then the model is good enough for the deployment part, and then the model goes and it is deployed. And that's the entire picture of how a predictive modeling or a predictive model is created, how machine learning really works. That's all about this particular video. In the next video, we shall be talking more about the different use cases in predictive analytics and various other things. In this video, we shall be talking about how does the model work. What is a model? I hope everybody is quite clear with this. But how does the model work? In predictive modeling, data is collected for the relevant predictors. A statistical model is formulated, predictions are made, and the model is validated or revised as additional data becomes available. The model may employ a simple linear equation or a complex neural network mapped out by sophisticated software. In this particular slide, you will learn what a predictive model is and how, by actively guiding marketing campaigns, it constitutes a key form of business intelligence and data analytics. We'll take a look inside to see how a model works. Predictors rank your customers to guide your marketing. Combined predictors means smarter rankings. The computer makes your model from your customer data. A simple curve shows how well your model works. So normally in simple layman's term, a model is something that is being created from the historical data. Using your historical data, that model is created, which has learned something from the data that we have. Based on the combinations and permutations possible in the dataset, the model has already acquired a lot of knowledge and has been trained. Now, when your model sees a new data point or for a new customer, the model will be able to formulate some equations inside it based on the type of model that is being created, and based on that the model will be able to predict whether that customer is going to be a fraudulent or non-fraudulent. And that's how your model works. In simple layman's term, let me just quickly talk about something called as neural networks. We all know human brains are created in a similar fashion. Our brain constitutes of neurons. Imagine we have a small baby. Let's say there is a small baby, and the baby is just a newborn baby, maybe 2 to 3 months old. That's it. Now, when the baby spots a cat, I'm pretty much sure the baby will not be able to recognize it's a cat because her memory is empty. Her memory is not aware of an object or an animal called as cat. But her mother or her father, her parents, teach the baby this is a cat. This is a cat. And it goes on for 6 months or 7 months. Now, in that duration of 6 months or 7 months, there are thousand instances where the baby has already spotted multiple cats. Maybe several times the baby has also encountered dogs. Several instances the baby has also encountered other animals. Now, which basically means from the last 6 to 7 months, the baby's brain is fed with so many images of cats, dogs, and different animals. And who is training the baby's brain? Her parents. So, her parents are the source of data. Her parents are helping her to understand who is a cat and who is a dog. After 6 months, if a baby sees a cat, there is a higher chance that the baby will be able to recognize. Why? Because 1,000 images has already been trained for cats, and 1,000 images for dogs, and 1,000 images for other animals has already gone to the baby's brain. Baby's brain is nothing but a concept similar to a machine learning or a neural network model. Her brain has already processed thousands and thousands of images, and that is because of the training part, the baby is able to recognize a cat or a dog. And that is exactly how a model works. You feed the data to the model automatically understands the pattern. With human eyes, it will be very difficult to understand the pattern. Somehow, using EDA or doing descriptive analytics, you will be able to come across some patterns, what the data is telling you. But it's very complex. Just by looking at the data, you will not be able to do that. But predictive model is something which has been fed with different types of historical data, and the model is good enough to do a prediction on an unknown object or an unknown data point or for a new customer. That is how your model works. The next big question is why predictive modeling? Why there is a need of predictive modeling? Honestly speaking, predictive modeling is one of the most important and critical aspects in the field of data analytics and data science. It is very much needed. Nearly every business in competitive markets will eventually need to do predictive modeling to remain ahead of the curve. Predictive modeling, also known as predictive analytics, is the process of automatically detecting patterns in data and then using those patterns to foretell some event. Imagine you are running a company and you are able to predict. Let's say you are running a telecom company. There are certain amount of people those are leaving the company every month. 20%, 25% of the people are leaving. Everybody's reason of leaving will not be same. Let's just accept that fact. If every customer's reason is not same, we will it's nearly impossible to predict who is going to churn, who is not going to churn. But using the help of predictive modeling, however, you will be able to predict whether a new customer or an existing customer is likely to predict in the next 6 months, 12 months, or 18 months. And that likelihood, because of that, if you are able to understand the reason why they are leaving by doing some predictive modeling, somehow, if you know the reason, you can probably pitch them with some offers and try to retain them. Even if you retain one out of 1,000 customers, it is a win-win situation for the company. And our ultimate goal as a data scientist or as a data analyst is to retain the customers. So our model will be able to predict the customers who is having a higher chance of getting joined. And if we get those list of customers, we can probably offer them something to kind of retain them. So predictive modeling has a lots and lots of use cases. We will be talking about each and every use case in the next particular video. Let's talk about the applications of predictive modeling. Now there are multiple applications of predictive modeling. Any model that is able to predict something is basically considered as a predictive model. So there are hundreds and hundreds of use cases across multiple domains to predict. If you talk about healthcare, in healthcare, you can potentially predict whether a customer is having COVID or not by just scanning their X-ray images. Or else you can analyze the blood sugar level or multiple other factors of different patients and probably can understand or predict whether a customer is likely to have cancer or not, or any other disease or not. So disease prediction is one of the classical examples in the healthcare domain. COVID detection, disease detection. If you talk about uh, some leaves, whether the leaves are having disease or not. Multiple use cases are there in healthcare which will be able to be a part of predictive modeling. Coming back to insurance, yes, there are again a lot of use cases in insurance. Cross selling, upselling. Upselling basically means a customer. There are two types of customer, two customers, let's say A and B, and both are kind of similar in nature. A has bought two insurance policies, let's say policy 1 and policy 2. B has bought policy 1. As A and B are similar in nature, if you recommend P2 to this user, there are high chances that the user will take. This is also an application of predictive modeling. So, be it analytical customer relationship management, healthcare, collection analytics, cross selling, fraud detection, risk management, all these are different use cases of predictive modeling. Apart from them, there are use cases like churn prediction, whether a customer is going to be churned or not churned, upselling, whether a customer will take an offer or not, disease prediction. By analyzing the voice data, if you are able to predict whether a customer is smoker or non-smoker, well, that is again a use case for predictive modeling. And there are thousands and thousands of use cases. If you are interested in a particular domain, let's say healthcare, banking, telecom, shipping, any kind of industry, just go to the website, go to google.com, search your domain, and just search predictive modeling in banking use cases, or predictive modeling in telecom use cases, or machine learning use cases in banking. Just simply google it out. There will be lots and lots of blogs that talks about various use cases, and you will be having a good experience and knowledge from that. Hi, let's talk about machine learning, otherwise called as predictive analytics. Machine learning is an application of artificial intelligence that involves algorithms and data that automatically analyze and make decision by itself without human intervention. It describes how computer perform tasks on their own by previous experiences. Therefore, we can say in machine learning language, artificial intelligence is generated on the basis of experience. So, before getting into the next topic, which is all about the types of machine learning and the further topics, let's try to talk about one of the most important question that everybody is confused with. And the question is, what is the difference between AI, machine learning, deep learning, and data science? These are the four jargons that are mostly used, and people are still not clear with each and every concept. Now imagine I'll draw a very big circle. Now this big circle is called as AI. AI, which basically means artificial intelligence. That means a type of intelligence that is achieved artificially. Whatever you have right now in your brain is your natural intelligence that you have inherited from your parents genetically. And somehow by reading and studying, you also make your intelligence more stronger. But that is still your natural intelligence. Artificial intelligence is achieved artificially. There are multiple areas of researches that basically leads to AI. And those areas of researches are these small circles. And one of these is basically your machine learning. So machine learning is one of the area of research that leads to AI. What are the other circles? They could be natural language processing, they could be robot process automation, they could be neural networks, they could be speech to text, text to speech, and so on. So there are multiple areas of researches that basically leads to AI. Now, what is DL? Deep learning. Deep learning is nothing but advanced machine learning. However, I have drawn NN here, neural networks, but it basically comes under ML. Probably I'll rub it off and I will write it down as computer vision. Computer vision is another area of research. So deep learning is nothing but a part of machine learning again. So if I draw machine learning, which is a zoomed version of this one, there is something called as deep learning. So anything that is not possible with your traditional machine learning algorithms, you can take help of neural networks and deep learning concepts to solve those problems. And what do we study inside deep learning? Concepts like how to analyze images, how to analyze voice data, how to analyze video data. All these things are not possible for ML algorithms, so we take help of DL algorithms. But ultimately, they are same, are part of machine learning. So DL is a subset of ML, which is again a subset of AI. But everything is fine. What is data science? Data science is nothing but the study of data. Some of you might already be a student of computer science or IT or electronics engineering or civil engineering. Now I'll take example of computer science engineering. Imagine you are a computer science engineer. What do you study in your bachelor's degree? You study about computers. You study about various computer programming languages. You study about C, C++, Java, and so on. So computer science is a major subject in your bachelor's degree if you are doing computer science engineering. So computer science engineering is simply nothing but the study of computers. Similarly, the study of data is called as data science. So it could use ML, it could use DL, it could be NLP, it could be robotics, RPA, it could be anything else. If you are trying to study data, that is basically your data science. So that's all about the overall concept behind machine learning, otherwise known as predictive analytics for a data analyst. In the next video, we shall be further talking about various types of machine learning, and I will tell you which type of machine learnings we should focus more on because they are the predictive analytics part. There is also a non-predictive analytics part inside machine learning, which we will be covering in the next video as well. Machine learning is a subset of AI which enables the machine to automatically learn from data, improve performance from past experiences, and make predictions. Machine learning contains a set of algorithms that work on a huge amount of data, be it historical or real time. Data is fed to these algorithms to train them, and on the basis of training, they build the model and perform a specific task. These machine learning algorithms help to solve different business problems like regression, classification, forecasting, etc. etc. Based on the methods and way of learning, machine learning is majorly divided into four categories, but on paper there are three: supervised learning, unsupervised learning, and reinforcement learning. We also have the fourth type, which is a combination of supervised plus unsupervised, otherwise called as semi supervised learning. Now, what do you mean by supervised learning? When it comes to machine learning, these are the three or four different types of machine learning. But when it comes to predictive analytics or the predictive model building, we will majorly be focusing on the supervised learning part. However, in this module, I will also talk about some of the unsupervised learning techniques like clustering. But usually clustering is not studied under predictive analytics because the reason will be talked in the clustering session itself, but in this next couple of videos, we will be majorly focusing on the supervised learning part. Supervised learning is further into multiple categories, one of them being classification. regression. Time series forecasting also comes under supervised learning. So, as the name suggests, supervised machine learning is based on supervision. It means in the supervised learning technique, we train the machines using labeled data. So, supervised learning is all about labeled data. The data is labeled. Here, the labeled data specifies that some of the inputs are already mapped to the output. More precisely, we can say first we train the machine with the input and corresponding output, and then we ask the machine to predict the output using the test data. I'll give you a quick example on what exactly do we mean by labeled data. I have a data set, 10,000 records, 9,000 fraudulent and 1,000 not fraud, sorry, my bad, 9,000 not fraudulent and 1,000 fraudulent records. So almost 10% fraudulent transactions. I will divide the data into training and test. Let's say training has 8,000 records and testing has 2,000 records. Now when you're creating the model which is being trained on the training data, it knows that 8,000 customers data is fed. It knows how many of them are fraudulent and how many of them are not fraudulent. So the labels are known. When the model is ready, it predicts on the testing data. The testing data is also known, but only the information, only the transaction information is passed here. We don't pass which transaction is fraudulent, which is not fraudulent while testing. You just pass rest all the columns. Let's say imagine you have a data set. There are multiple columns, column 1, column 2, column 3, column 4, and this column tells whether it is a fraud or a not fraud. Fraud, not fraud. You don't pass this column while predicting. But once your predictions are done, you compare the predictions value with this actual value. That is what is called as labeled data. So we usually deal with labeled data. We know that some of these transactions are fraudulent and some of them are not fraudulent. So they are called as supervised learning. What do you mean by regression? Now this is an example of classification because we are classifying. What do you mean by regression? Regression is another type of supervised learning. Well, classification algorithms are used to solve the classification problems in which the output variable is categorized as fraud, not fraud, yes or no, churned or not churned, diseased or non-diseased, and so on. Some of the classic examples in classification are spam detection, email filtering, fraud detection, churn analysis. All these are different use cases, disease prediction, and so on. There are multiple algorithms inside classification. We will be focusing on some of the important ones in this particular module, but there are more than 20, 30, 40 algorithms. Some of the algorithms are k nearest neighbors, decision trees, random forest, logistic regression, naive Bayes classifiers, XGBoost, cat boost, ada boost, and so on. Many algorithms are there, but we will be focusing on some of the important ones in this module. After classification comes regression. What do you mean by regression? Regression algorithms are used to solve regression problems in which there is a linear relationship between input and output, and based on that you use to predict the continuous output variable. For example, I'll give an example. Let's say you have multiple customers height and weight. Given certain height, you have some weights. Now what you do is you start plotting them. First second, third data point, fourth data point. Now, if somebody asks what will be the weight at a certain height, let's say at this height, what will be the weight? Now, using the existing data, what happens here is you create a linear relationship. Once you create a linear relationship, and then you kind of plot this data point on top of this line, wherever it kind of deviates or dissects the line, that becomes your predicted weight variable. Predicted weight. That means based on one particular variable, you are predicting the second variable. House price prediction is an example of regression. Let's say there are different types of houses, different areas, and you are predicting the price. Let's say in the existing data, for a 500 square feet, let's say the cost is 2 million. For 1000 square feet, it is 4 million. For 600 square feet, it is 3 million, and so on. Somebody asks you what will be the price at 200 square feet. So using this data, let's say you try to plot area and price. 2, 4, 6, 8, 10. Price is 1, 2, 3, 4, 5, 6. So at 500, it is 2 million. So 2, 4, 5, it is 2 million. Somewhere here. At 1000, it is 4 million. Somewhere here. At 600, it is 3 million. Somewhere here. So if you draw a line that goes through these points, not exactly through all the points, but you have to find that line which is closest to these data points. Now there are techniques to find that line, and that's all about your regression problem. I'm just explaining you from a very overall point of view, from a very layman's point of view. Now once you get this best fit line, you have to find what is the price at 200. So 200 price will be somewhere here. So let's say the value is around I don't know, 1.5 million. So you predict that the value at 200 square feet is around 1.5 million. So that is a regression problem. So problems like house price prediction, rainfall prediction, temperature prediction, and all those things, weather forecasting, comes under your regression problem. Forecasting is an extension of regression. Forecasting is an extension of regression, but majorly we consider a problem as a forecasting problem, time series forecasting problem, when it has a date component in it. So let's say you also have a date component. That means on this date the price was this, on this date the price was this, on this date the price deviated. Now if somebody asks at this particular day what will be the price, in that case it becomes a forecasting problem, time series forecasting problem. So in time series forecasting problem, time plays the most vital role. So time is the most important feature in that. So once we jump into regression and forecasting, you will have better understanding on that. What are some of the advantages of supervised learning? Since supervised learning work with the labeled dataset, so we can have an exact idea about the classes of objects. And these algorithms are helpful in predicting the output on the basis of prior experience. These algorithms are not able to solve complex tasks though. It may predict the wrong output if the test data is different from the training data. Now, there are some drawbacks of supervised learning as well. Let's say one of the examples. I have a data set, 10,000 records, 9,000 not fraud and 1,000 fraud. Imagine while creating the training and test samples. Imagine all these 1,000 records comes into the training data. Or maybe just 100 records comes into this training data, for example. Just very few records. Now when you are creating model, out of the 8,000 records, 7,900 are not fraudulent. Only 100 are fraudulent. That means the model is not learning properly. Imagine the model is being trained with 7,900 cat images and only 100 dog images. Will the model be able to learn? No, because there are very few records from one particular class. So the model will not be able to learn. So dividing the data into a proper training and test is very important. So sometimes your predictions may go wrong. So when the predictions goes wrong, you always have to come back to step number 1 and revise everything. And that is one of the reasons why predictive models or machine learning models are always an iterative process. Another drawback of supervised learning will be it requires a lot of computational time to train the algorithms. So, summarizing everything, the advantages of supervised learning will be it will be able to predict the classes if you have distributed the classes properly. It takes help of the prior experience. Some of the disadvantages will be it might not be able to solve complex tasks. You always have to worry about your split on how your training and test split happens, and computational time is high. So memory consumption will also be high in order to run machine learning or supervised learning problem. Some of the applications of supervised learning will be image segmentation, medical diagnosis, fraud detection, spam detection, and so on. Now, talking about unsupervised learning. Unsupervised learning is a type of learning where you deal with unlabeled data. It is different from the supervised learning technique and deals with unlabeled data. Imagine a similar example. Similar example can also be treated as an unsupervised learning technique. Imagine you have a data set, 10,000 transactions. You don't know which of them is a which of them is a fraud and which of them is a not fraud. So there are two solutions to it. Either you convert it into a supervised learning problem by manually labeling them using your domain expertise. If you are able to do that, it becomes a supervised problem. Otherwise, treat it as an unsupervised problem and try to do some clustering techniques to understand which transactions are similar in nature. So that is also possible. So unsupervised learning is a particular type of learning where the data is not labeled. If somebody gives you that, hey, you know what, these are the list of news, can you create groups out of them? If you know how many groups do we have to create, let's say we have to create 3 groups: entertainment, sports, and politics, and you know that existing news that has been given has those labels. In that case, you will be able to create groups and you will be able to create models. If a new news comes in, you will be able to predict whether it falls in this category or that category. But if you don't know how many groups, then in that case it becomes an unsupervised learning problem. Some of the classic examples of unsupervised learning problem is again fraud detection if it does not have labels. Another classic example is if somebody gives you a list of millions of customers and tells, can you do some customer segmentation? I want to find which customers are similar in nature. Again, in that case, unsupervised learning will be used. Some of the algorithms under unsupervised learning are k-means clustering, mean shift, DB scan, hierarchical clustering, otherwise called as agglomerative clustering. Concepts like PCA, LDA, all these things comes under your unsupervised learning. In this particular module, we will be covering some of the clustering techniques, though they are not part of predictive analytics. Lastly, another type of learning is reinforcement learning, which basically means that it is a feedback based learning. That means you take feedbacks and try to rectify your mistakes. For example, you are talking to a chatbot A chatbot usually learns with every new communication. If you are making new communications with chatbot, most of the chatbots try to learn by themselves automatically. Those type of chatbots are created using reinforcement learning. So in simple terms, reinforcement learning works on a feedback based process in which an AI agent or a computer software component automatically explores its surrounding by hit and trial, some taking some actions, learning from experiences and improving its performance. Again, these are some advanced topics which is again not required. So we'll be majorly focusing on supervised. And the last type is semi-supervised, which is a combination of supervised and unsupervised. This could be an example of semi-supervised. When you have an unsupervised data set, you are manually labeling them, making a supervised data set, and then using supervised models, you are solving them. That could be a use case of semi-supervised learning problems. So that's all about types of machine learning in a nutshell. In the next video, we shall be jumping into supervised learning and we'll be trying to learn more and more concepts related to them. As we discussed in the last session that supervised learning is further having multiple types, one of them being classification and one of them being regression. We'll be talking about regression in one of our future videos. Let's try to talk about classification. As the name suggests, classification is a technique where you deal with classes. Classification algorithms used in machine learning utilize input training data for the purpose of predicting the likelihood or probability that the data that follows will fall into one of the predetermined categories. One of the most common applications of classification is for filtering emails into spam or non spam as used by today's top email service providers. So we'll try to talk about spam and non spam example. Let's say you have multiple emails. Some of these emails are tagged as spam and some of them are tagged as not spam. Now, obviously, when an email is tagged as spam, could be because of multiple functionalities or multiple characteristics because of which it is marked as spam. Let's say their body has a word called as offer, or their title has something called as collaboration or lottery. So these kind of words are important words and they basically help you identify spams. So basically, based on the data that you have, if you train it, obviously you divide it into training and test. Once you train it, the model will be able to understand why this is treated as a spam and why this is treated as a not spam. So when a new email comes in, based on the existing data that has been trained, it will be able to predict whether a new email is a spam or a not spam. And based on that, all the email providers work. In Gmail also, you might see some of your mails going into spam. That could be because of the inbuilt spam detector or spam filtering technique used by Gmail. Sometimes some of these emails are not spam. They are tagged as spam by Gmail. If you go ahead and mark them as safe, next time automatically it will be rectified and they will not push those kind of emails to your spam folder. Another example of classification will be, let's say, fraud and not fraud, and obviously the data set having the labels. Let's say I am having millions of transactions. I know some of them are fraud and some of them are not fraud. I divide the data into training and test. Training data, I create a model. Now the model knows the characteristics of fraud and not fraud. So when you test it from the testing data, it basically uses its own knowledge from the training data and predicts for the testing data. And whatever it predicts, We compare predictions with the actual labels and then come up to a conclusion whether the model is performing well or not. And similarly, we also create multiple models. And whichever is performing good, we kind of consider that for the next step and then do further fine tuning and then finally create our final model which is ready for deployment. So that's all about classification in nutshell. As I already discussed, in classification there are multiple algorithms. One of them is KNN, K nearest neighbors. One of them being decision tree, random forest, naive Bayes classification, Bayes, logistic regression. Logistic regression, even though the name is regression, but it is considered as a classifier. Apart from that, support vector machines, XGBoost, CatBoost, AdaBoost, extra trees classifier, and so on. There are many such algorithms. Learning each and every algorithm is not possible, but each and every algorithm somehow does the same task. They understand the training data and based on that they understand the patterns and predict on the testing data. And once your final model is ready, when a new transaction, an alien transaction comes in, it will be able to predict whether it is fraud or not fraud. That's the task of all these algorithms. But the way these algorithms work, the concepts, the mathematics, the statistics behind the algorithms are completely different. In the next video, we shall be talking about some of these algorithms, which are one of the most important algorithms for classification. And once we are good with the explanation part of the algorithms, we will also take a public data set similar to this one, like a fraud detection or a churn prediction data set, and we will be implementing these algorithms in Python using some of the libraries in Python. In this video, we shall be talking about the first algorithm inside classification, which is k nearest neighbors. Now, what do you mean by k nearest neighbors? It simply means how many nearest neighbors do we have for a particular data point. And based on that, we will be assigning that data point to a particular class. In simple terms, it is a supervised machine learning algorithm, and k nearest neighbors algorithm can be used for both classification and regression. It is one of the simplest machine learning algorithms based on supervised learning technique. But in this particular case, we will be using this algorithm for classification, and we will see how k nearest neighbors algorithm works and how is it able to classify. The number of nearest neighbors to a new unknown variable that has to be predicted or classified is denoted by the symbol k. Now let's take an example of this particular diagram. Before that, we'll try to draw a diagram from scratch. So let's say this is my predictor 1. So I'll take a small example. I'm doing the same churn analysis dataset. One of the columns I have is churn, which says whether a customer has churned or not churned, churned or not churned, churned or not churned. And there are multiple features. Now, as we are drawing a two-dimensional graph, I can only pick two features because it is visually not possible to plot 3D, 4D, 5D or n-dimensional graphs, right? So instead of multiple predictors, I will be using two of them. Let's say one of them is age and one of them is salary, age and salary. Now, based on my age and salary, I will try to plot which of them are churned and which of them are not churned. So for churned, probably I will plot this churned, 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 churned. For not churned, that means active, probably active, 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 active. Now these are my 6 data points from active, and 1, 2, 3, 4, 5, 6, 7 data points from my churned list. What does this mean? This means this graph has been plotted by using 13 data points. Now, the question is very simple. If I have a particular age of an employee and salary of an employee, I should be able to predict whether that customer is going to be churned or not churned. As simple as that. So how does KNN algorithm solve this problem? So we'll try to plot this data point here. Let's say arbitrarily the data point is, I'll use a separate color. Let's say this is the data point. Now my task is to find the k nearest neighbors to it. Now what is k? K value depends on the type of classification problem. In this case, we are using two classes. We are having two classes, which is churned or active. Churned or not churned. So this type of classification problem is called as a binary classification problem. You could also come across multiple other classification problems where there will be more classes. For example, you are having multiple images. Some of them are cats, some of them are dogs, some of them are horses. Now this is a multi-class classification problem. Anything that has more than two classes are called as multi-class. In this case, it's a binary problem. That means we have two classes. So normally in case of binary problems, your k can be any odd number starting from 3 or n plus 1. So 3, it could be 5, it could be 7, it could be 9, dot dot dot. What is the optimum value of k? You can use as per your expertise, as per your knowledge. It's a hit and trial process. Let's start with 3. What do you mean by k equals to 3? That means 3 nearest neighbors. That means for this particular data point, I need to find the 3 nearest neighbors. And how to find the 3 nearest neighbors? What I can do is, I'll probably draw a line from each of these data points to that final data point. 1, 2, 3, 4, 5, 6, this, right? So what I'm doing is I'm trying to find the distance between multiple points to this particular data point, and I want to find what are the 3 nearest neighbors. That means which data points are the 3 nearest data points to the cross object or to the new data point for this particular data point, right? Let me erase it little bit so that it does not create confusion. Yeah. Now, before getting into this, I'll try to talk about another mathematical concept, which is how to find the distance between two different points. I'll try to take help of this graph. Let's say there is a point here. Its coordinates are 2 and 3. There is another point here. Its coordinates are 8 and 6. Let's say I will give it as A, I'll give it as B. Now, mathematically, what will be the distance from A and B? Mathematically, the distance from A and B will be x1 minus x2 square plus y1 minus y2 square root over. That is the mathematical formula to find the distance between two lines. Okay, so what is my x1? My x1 is 2. 2 minus 8 square. Your x1 can be 2, it can be 8, because 2 minus 8 whole square and 8 minus 2 whole square are same, right? Minus 6 whole square is also 36, plus 6 whole square is also 36. So it can be either way around. And y1 minus y2 will be 3 minus 6, 3 minus 6 square root over, which will be 36 plus 3 square 9 root over, which will be 45 root over, and root over of 45 should be somewhere around 6.7 or 6.8. You can cross check it with your calculator. 45 root over is 6.7. So that is the distance between A and B. Another technique is also there, using the hypotenuse technique, right angle triangle. Let's say I will name it as C. Obviously this will be in the x axis, it will be 8, in the y axis it will be 3. So what is the distance here? The distance here is 6 units and the distance here is 3 units. Now my hypotenuse square is nothing but my base square plus my height square, right? And AB will be the root over of that, which is 6 square plus 3 square root over, which is again 45 root over, which is 6.7. Same. So we will be using this technique. This particular technique in mathematics is called as Euclidean distance. So if somebody asks you between 2 points, what is the formula of Euclidean distance, you can talk about this formula. So coming back to this example, what happens here is each and every data point till this x is our new data point, which our KNN algorithm is going to predict. So I'll be calculating the distance between all the points to this x, and let's say this and this are the 3 nearest neighbors, or these are the 3 data points having the lowest Euclidean distance from the new data point. Now out of these 3, 1 belongs to class A and 2 belongs to class B, and as per voting this becomes class B, whatever the class is. It could be churned or active, right? And this is how it works. If you want to consider k equals to 5, again let's say the 4th lowest is this and the 5th lowest is this. Now as per k equals to 5, it basically belongs to class A. So a lot of hit and trial processes goes on internally, and you will be able to get the optimum k value, and you will also be able to predict the output, predict the class of your unknown data point. That is all about k nearest neighbors. In the next example, I will take an example using an Excel sheet, using a small use case, and I will be explaining you how to calculate k nearest neighbors, how to use k nearest neighbors to solve that problem. And further we will jump into Python code, where we will be implementing this algorithm, and the Python code is going to be one of the easiest things to implement, because we will be using an existing library and we will be calling this algorithm and solving a small problem. That's all about this particular video on the basics of KNN. In the next videos, we'll be talking more about KNN using other examples. So we'll jump into an example where we will try to solve this particular example using KNN algorithm, using the K nearest neighbor algorithm. Now let's try to explain this particular use case. I have list of multiple players, their respective ages and their respective genders, and based on their age and gender, what type of game they prefer, whether it is cricket or football. Now the question here is, for a new data point, for a person named Satyajit, whose age is 30, whose gender is male, which type of game he or she will prefer? That is the question. So let me write down the problem statement. For a given player, which type of game he or she will prefer? We need to predict the game. That is my problem statement. Now, in the previous example, I showed a simple example taking two variables, right? This and this, multiple data points were there, and for a new data point we had to calculate the nearest neighbors, right? Now here I had taken two features, feature 1 and feature 2, and we were able to visualize it very properly, right? So in a two-dimensional graph, if you have a data point like this and another data point like this, and its coordinates are 2 and 3 and 8 and 6, the formula of AB is very simple, x1 minus x2 square plus y1 minus y2 square root over. But if this goes into three dimensions, which is little bit difficult to plot, but imagine I have A and I have B. Let's say the coordinates of A are 2, 3 and 1. The coordinates of B are 8, 6 and 5. Because they are three dimensions, right? So the formula here changes from this to this, x1 minus x2 square plus y1 minus y2 square plus z1 minus z2 square. So the number of dimension increases, the formula becomes complicated and complicated, right? But the formula is easy enough to remember. In this particular example, if you look at this example, we have feature like age and we have a feature like gender. Name can be ignored because name has no relevance in solving a classification problem. And I have a feature called as game, which is my y variable. We need to predict this. What is the problem in the data right now? Age is a numerical attribute, but gender is a categorical attribute. So what we need to do is we need to convert it into numerical using some encoding techniques. Now, which type of encoding techniques is most preferable in this case? You can go for dummy encoding or a label encoding, but again, label encoding is not used for X variables, so we will be using a dummy encoding. Before getting into a dummy encoding, let's try to convert it into one hot encoding first. So how can we convert? Gender M, two new columns, gender F. Wherever I see M, it will be 1, this will be 0. Same for all, same for this. 0 and 1. Same for all this, right? Now these are my two dummy variables. What is the difference between dummy encoding and one hot encoding? In one hot encoding, you will have n number of dummy variables, but in dummy encoding, you will have n minus 1 number of dummy variables. Why? Because you are getting redundant information from n variables, so it is better to remove one of them. So I'll randomly remove one of them, delete column, and this becomes my final column, and I will strike this down. So my problem statement is clear. I have age, I have gender, and we need to find which person is playing which game, and based on that we'll be able to predict for this new customer. So I'll try to draw this. On my y-axis I will have the gender M, on my x-axis I will have age. Let's say this is my 0 and this is my 1. First one is 25-1. Let's say here 29-1. Sorry, 25-1, 29-1, 11-1, 11-1, 18-1. 18-1 is somewhere here. 29-1. Again, 35-1 somewhere here. 18-0, 18-0, 21-0, 22-0, 31-1. Something like that. These are my multiple data points. Now, the first data point belongs to cricket. This basically belongs to cricket. Cricket, cricket, cricket. 18 is football. Okay. It's a little bit confusing. Let me just do it from scratch. We'll try to use cricket as red and football as blue. So 25-1 cricket, 25-1 cricket, 29-1 cricket, 29-1 cricket, 11-1 cricket, 18-1 football. So this will be football. 29-1 cricket, 35-1 football, 18-0 cricket, 21-0 football, 22-0 football, and 31-1 football. Now these are my multiple data points. Now my new data point, which is in purple color, is 31, somewhere around here, right? 31. Now what we need to do, based on my k value, let's say my k value is 3. It's a binary classification problem. Let's say my k value is 3. I need to find the distance between all these points, right? And we need to find which 3 of them are nearest neighbors. Now for example, visually these 2 and this one are 3 nearest neighbors, so this becomes cricket, right? That is all about k nearest neighbors. So let's try to solve this problem. For the first one, what will be the Euclidean distance from this point, from 25-1, from 25-1 till 31? What will be the distance? It will be 25 minus 30 square plus 1 minus 1 square root over, right? 1 minus 1 square cancel, 25 minus 30 square will be 5. So here my Euclidean distance will be 5. Similarly, it will be 1, it will be 19, this will be 12, this will be 1, this will be 5. Now this is class 0, 18 and 0. So what it will be? 18 minus 30 square plus 0 minus 1 square root over. So 12 square is 144 plus 1 root over. 145 root over should be around 12.05 or something like that. 145 root over is 12.04. Okay, so I'll write down it as 12.04. Similarly, this one will be, let's say, 9.05, and this one will be around 8.05, and this one will be again 1, right? These are my multiple Euclidean distances from this point to all these points. Which are the nearest 3 points? So the nearest ones are the ones having the lowest Euclidean distance. Let's say this one, and this one. Now you take, here it is cricket, here it is cricket, and here it is football. Now there are 3 cases of cricket, 2 cases of cricket and 1 cases of football. So if you take a voting, it becomes cricket. So my final output will be, this person with age 30 and gender as male will be preferring cricket as per my k nearest neighbors algorithm. If you talk about k equals to 5, this is again football and this is cricket. So again 3 cricket and 2 football, it will again be cricket. And this is how your k nearest neighbors algorithm works. That's all about this particular small example. In the next video, we shall be jumping into the Python part. We'll be implementing one particular example. We'll be using KNN to build our predictive model, build our predictive analytics model. Hi, in this video, we shall be talking about how to implement our first predictive model, our first classification related predictive model using KNN algorithm. So I have used Google Colab and I have mounted my Google Drive so that I can access the files from my Google Drive and I can start working on my model. In case you are working on a local Jupyter notebook or Spider notebook, in that case you have to place your files in your local machine and pass the entire file path while reading the file. So in this case, as I told, I am using Google Colab and I have mounted my Google Drive. So I'm using a location from my Google Drive, which is this AI Data Science and Analytics, and this is the file name. So I have just passed this. press shift enter and our data frame will be ready. You can get started with doing some minor ED activities by printing the head, printing the info, which gives you an initial idea about the dataset. Now in this case, we have 7043 records. Customer ID, gender, senior citizen, all these are different columns. I can spot one mistake here. Customer ID, gender, and senior citizen, partner, dependents. If you look at total charges, now total charges is nothing but a numerical attribute. If you see total charges, it's a numerical attribute. But in the information, it is showing this as an object. Now what we will do is we will convert this total charges to a numerical attribute. So I will do df dot total charges equals to df pd dot to numeric, and I will be passing the same total charges. So my total charges is now a numerical attribute. If you just print info again, you will be able to see total charges is now a float object. And you can see that there are 7032 records, which means there are 11 missing values in the total charges column. Now again, as per your missing values logic, you can impute them or you can get rid of them. In this particular scenario, there is almost 11%, almost 11 records, which is 0.15%, which is less than 1% of missing values. So I will simply get rid of them. I will do df.drop na how equals to any, and then in place equals to true. That means wherever there is a null value, drop it. That is what I am doing. Now once that is done, that's how your data frame looks like, right? Now I'll try to draw a simple architecture which will help you to understand how to create your classification model. You have your data set. In this data set, if I look at the distribution, df.churn.value counts, my distribution is almost 5000 and 1800. If I calculate the percentage, almost 73, or let's say almost 73% of active customers, 27% of churn customers. This is what the data has. What we did now was a little bit of EDA, and finally we are with a clean data. Now what we will do is divide the data into training and test. This is what we will do. And once that is done, your training data will be used to create models. Model 1, model 2, model n. And once models are created, your testing data will be passed. We will be getting predictions, and we will be comparing the predictions to check which model is best. Right now, we are only using KNN classifier, so we will be creating only one model. In the next session, when we are studying about decision trees, after that we will be creating decision trees. After that, we will be creating random forest and so on. And at the end of the classification, you will be able to see a similar architecture like this, and we will be able to compare multiple models. Okay, so let's go ahead and divide the data into training and test. Before that, I will be dividing the data into X variables and Y variables. So what is my Y variable in the data? My Y variable is this churn column, which talks about which customer is active, which is churned, which is this column, right? So that will be my Y, and X will be others. So I will do df.drop. Customer ID is not important, so I will drop them, and I will drop the churn. Once that is done, axis equals to 1. Done. Y equals to df.churn.values. I'm just taking the churn values in y, right? Right now I have my x and y. If you want to print your x and y, you can go ahead and print your x and y. X is your same data frame without the churn column, and y is your churn column, right? Now, if you want to print the columns of x, you can just do x dot columns. Now, what I need to do is, if you look at x, gender, partner, dependents, phone service, multiple phone lines, all these are categorical attributes, right? So what we need to do is we need to convert categorical features to numericals. And what we need to do here, if you recall your previous module, we studied about feature encoding. So I will be performing feature encoding. So x equals to pd.getDummies. I will be calling my x, and then I will be calling all the columns equals to. So I will call everything and then I will delete it. I will delete the unnecessary columns. And after that, I will be doing drop first equals to true. Why? Because I am going to do the dummy encoding. If you remember, if there is a column like location, Malaysia, Indonesia, Korea, Malaysia, 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 and so on. What we do is we create multiple columns like this, right? Wherever you see Malaysia, that will be 1, others will be 0. Wherever you see Korea, that will be 1, others will be 0, and so on. And these are all dummy features. So when you are creating dummy features, that's basically called as one hot encoding. But in dummy encoding, we basically get rid of one of these features because it's passing redundant information. So you either you delete this or delete this, anything is fine. So here we are deleting the first column. So gender, senior citizen is not required. Partner, dependents, phone service, tenure is also a numerical attribute. Phone service, multiple lines, internet service, online security, online backup, device protections, tech support, streaming, this contract, yes, contract, paperless billing, payment method, and these two are numerical, so I'll delete it. Okay, now I'll run this. Once that is run, you can also check your X. I will just do head of 1 so that I can just check one column, and you can see everything is numerical now. Partner, yes. Dependents, yes. And that is how the data frame looks like. Now your data is well ready to be passed to your models. Before that, I will be performing this step of dividing the data into training and test split. Splitting the data into training and test. So here I will be using sklearn libraries model selection, and then I will be calling xtrain, xtest, ytrain, ytest equals to this, and pass your x and y, and test size equals to something. Now this something basically means that when you are dividing the training and test samples, your training should be 75% and your test should be 25%. Okay, this is what is happening here. I'll run this. Now if you want to check the xtrain data, you can see 5000 records and length of x test somewhere around 1000 records, you can see. And if you want to check, they will be divided into 3:4 ratio. 3 portions training data and 1 portion testing data. So our next step is doing feature scaling. Feature scaling is basically done in order to scale down the features. As you can see, when you are printing the data frame, Some are in zeros and ones format, some are in tens format, some are in hundreds format, something like that. So in order to get everything to a single shape or to a single scale, we have to perform feature scaling. I hope everybody remembers about the two most important feature scaling technique. One of them is standardization and one of them is normalization. Normalization is x dash equals to x min divided by x max minus x min. Standardization will be x minus mu by sigma, right? So I will be performing standardization from sklearn dot pre-processing import standard scalar. SC equals to standard scalar transform x test equals to SC dot transform test. Now I would like to explain this piece of code. Why did we perform fit transform on xtrain and only transform on train? Only transform on test. Let's try to understand. You have a data set, you divide it into training and test. So when you are performing fit underscore transform, basically you are using your training data to fit into your models. So only training data information will be passed. That means whenever you are doing this standardization, x dash equals to x minus mu by sigma. Out of these records, let's say mu is 10 and sigma is 3. Imagine. So based on this, your data will be scaled, your training data will be scaled. Again, based on this, your testing data is also scaled. That means you are only fitting the training data. Out of this 75% records, whatever mean or sigma you are getting from this data, you are using the same mu and sigma for this data also. So when you are converting your testing data, you are also using the same formula where mu and sigma remains the same from the training data. You are not recreating the mu and sigma from the testing data. So that's why we are only doing transform for testing data and doing fit underscore transform for training data. Okay. Now our next step is you can just print your training and test data, and you can see they are all scaled values. So that's all about your basic things till here. We have kind of cleaned the data, deleted some of the null values. We have divided the data into training and test samples, and we have also performed feature scaling step here. In the next video, we shall be creating our 𝐴𝐻𝐸𝐿 classifier, and going forward, we'll also be creating decision tree, random forest, and so on. In the last video, we talked about how did we use our data set, how did we perform some null value imputation, how did we also kind of divided the data into X and Y and then further into training and test samples. We also performed some feature encoding technique, especially dummy encoding, to ultimately get all the columns into numericals. And then we also performed some standardization technique, some feature scaling technique. Now, so far our data is almost ready. If you want to go ahead and check it out, you can check it out that my training underscore transform data and my testing underscore transform data looks like this. Now our next step is to create our classifier. So I'll call my classifier 𝐴𝐻𝐸𝐿 classifier. Now simply, if you don't remember any classifier's name, it's super simple. Just try to search sklearn 𝐴𝐻𝐸𝐿. You will be getting the link on top where your scikit-learn.org website will be shown, and here is the details about the K neighbors classifier. classifier implementing the k nearest neighbors vote. You can see whenever you are calling a classifier, there are some attributes, there are some parameters that are also needed. Now these parameters are basically called as hyperparameters. If you don't pass anything, the default values will be gone. And if you pass something, the values will be overridden. So let's try to call our classifier from sklearn dot neighbors. From sklearn dot neighbors, import k nearest classifiers. So I will name it as call the knn classifier. Initiating the classifier. So I will start my classifier model equals to this. Now if you pass this, that means you are calling the default classifier. That means all these parameters are not changing. But let's say you want to override this n neighbors equals to 5. Instead of that, you want to pass n neighbors equals to 7. In that case, these values will be overridden. Now, one thing you might be asking that what is the best value? Is 5 the best value, or 7 the best value, or 3 the best value? So the best value, in order to get the best value, what we do is hyperparameter optimization, which is again a very advanced machine learning topic which we are not covering here. So if you go back to your diagram, what really happens is you clean the data, you get this training and test, prepare your models, and then let's say this model is performing best. Model 2 is performing best. In real-time scenarios, what happens is you take this model and try to recreate the model by doing some feature engineering steps. I will name it as model 2's first version or model 2's second version and so on. Let's say out of all these feature engineering steps, this is the best model. Then you again go ahead and do some hyperparameter optimization step to increase the accuracy, to enhance the models. So this is a very advanced step where we arbitrarily go and change all these parameters, run the models again and again and again and again, and we see which of these models are running the best. In simple terms, hyperparameter optimization is, imagine you are running the first classifier like this, second classifier like this, and third classifier like this, and weights equals to distance, let's say. That means these are the three different versions of your classifier. This is giving you 80, this is giving you 81, this is giving you 78. That means this is the best classifier. That's basically your hyperparameter optimization. Coming back to the code, I will be using the default configuration and then passing the data to classifier. Model.fit, you have to use the fit function to pass the data and then run this, and your classifier is ready. Once your classifier is ready, going back to the model, your classifier is ready with training data. What we need to do right now is pass the testing data for predictions. So I will call my model.predict function and I will pass my testing data and whatever predictions I am doing on testing data. Let's say testing data has 100 records. So I will be getting 100 predictions, right? So I will be storing them in a variable called as 𝐲𝐻𝐻𝑝red. Run this and your 𝐲𝐻𝐻𝑝red is ready. If you want to check 𝐲𝐻𝐻𝑝red and 𝐲Test, that's how your 𝐲𝐻𝐻𝑝red and 𝐲Test looks like. For initial few records, they have done a good job. You can see here for one record it is no, but it is predicting as yes. So there are mistakes of course. So we'll try to check the mistakes. And once your model is ready and once your model has predicted, our next step is to check Out of these 100 testing records, how many of them are correct predictions, how many of them are wrong predictions? Based on that, you will be calculating the accuracy, right? Let's say out of 100, there are 80 active customers and 20 churned. But out of this 20 churned, our model has predicted 16 correctly. And out of this 80 active, our model has predicted 70 accurately. That means 86 is the total correct predictions and total records are 100. So your accuracy is 86%, right? So in order to calculate accuracy, simply what we need to do is classification metrics to check how the model is behaving. So I will be calling from sklearn.metrics import accuracy score and then import accuracy score, and then I will pass my testing data and pass my prediction data. My accuracy score is, I'll just so my accuracy score is around 75.6%, or else if you simply print it also should be okay. My accuracy is 75.6%, which is obviously not bad because we have not performed a lot of steps. I have just simply created a basic classifier with some basic, feature encoding and feature scaling. There are a lot of things that can be done in order to take this accuracy from 75 to 85 or 90. Now, the most important thing is that is fine. Training, you have already trained the data, you have already predicted from the testing data. What if you have a customer coming in, and for that new customer, you want to predict whether the customer is going to be churned or not churned for a new customer? So I will mark it as new data prediction. That means a data that is not a part of your entire data set. Let's say I'll quickly take one of these examples. Now this is my testing data. Let's say the okay. So let's say I'll take some random data sets here. Data equals to okay. Let me just print my x test dot head 1. So based on this, I will be passing some information. Okay. So let's say my customer is senior citizen, like it's not, he's not a senior citizen. Let's say tenure is 2, monthly charges is, let's say, 87, 178, gender is 00010, so 30 columns, right? Now everything is yes or no, yes or no, yes or no, yes or no, and I think last two columns, everything is yes or no. Okay. Yeah, everything is yes or no. So I will just quickly pass some random values: 00010, 01, 0000001, 0000000. 1 0 0 1 0 0 1 0 0. How many columns? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30. Okay, so that's my data, that's my new data. So whatever the customer, whenever you are testing your model for an unknown customer which is not a part of your original data set, that means somebody has to enter the information about the customer, right? So when you enter all this information about the customer, whether he is a senior citizen or not, whether what is the tenure, what is the monthly charges, what is the total charges, whether he is a male or not, whether he has partners or not. If he has no partners, then it will be 0. If he has dependents, it will be 1. If no dependents, it will be 0. So you have to pass everything here. Now, look at this. When you are getting your original data, what you are doing here is you are doing the standard scaling, right? That means you are transforming the data. So, obviously, you cannot pass this raw data to your model. So, we'll also have to transform it. So, I will mark it as data underscore sc equals to sc dot transform data. And once that is done, single equals to model dot predict data underscore sc, and then I will print my single. I'll run this, and you can see for this particular record the model is predicting as yes. That means the customer is likely to be churned. You also need to do one thing. For example, you want to understand the probability. In that case, you can also run the probability predict underscore proba, which basically says that there are chances, there are 80% chances that this customer will get churned. That is what the data is telling. And of course, there are a lot of things that can be done here. As I told, feature engineering, hyperparameter optimization, all these things are very advanced topics that's not required for, at least for building your first predictive model. And of course, that's all about KNN. So what we have learned so far is how to build our classification model using KNN classifier. In the next module, in the next video, once we learn about decision trees, the rest of the codes are going to be very simple because I'm going to take help of this piece of code to create the code for decision trees, random forest, and so on. Hi, welcome back. In the previous video, we got started into the practicals of creating our classification model. We started analyzing the data. We did minutely little bit of feature encoding processes. We also did some sort of normalization or standardization. And right now, our data is ready to get started with creating the first model. So now jumping on to vibe coding, where we will be leveraging AI to write down codes. Now that's the whole agenda of this entire program, on how you can leverage heavily on AI to get started with programming, get started with SQL, get started with Power BI, etc. etc. Right? So moving on, for this exercise, I'm going to use grok.com, and the reason is known. I have already talked about this thing in many of my previous videos that this is my first preference. ChatGPT is something I usually don't use, and that's a very personal choice because I have used ChatGPT heavily, I have used Grok heavily, I have used some other tools. Somehow I like Grok. That's a very personal call, but in case you want to use something else, it's completely up to you, right? Eventually, it's going to be a similar tool, right? Where you will be asking some questions. So, in case you want to choose Grok, I will recommend you this is how you can choose. The very first thing that you can do is, let's say you are going to work on this project, right? Let us first import the libraries. Now this is something which is very basic, so I'm not taking the help of ChatGPT or Grok for writing down these few lines of code. And after importing, let's say df is equals to pd.read csv, and then I'm going to pass this copy path and done. And this is how my data looks like, right? So the problem statement is pretty much understood. This is a churn prediction data set, basically a data set from a telecom company of multiple customers, and there is a column called as churn, which basically tells whether the customer is churned or not churned. Simple. Eventually it's a project, right? So how do we get started with coding, or sorry, get started with AI tool like this? Well, there are two options. Either you start a new chat or you start a new project. I always recommend to start a new project, because inside the project the instructions are already there with Grok, so nothing to worry about. And chats sometimes could be lost. As you can see on my screen, I have three different projects, and I cannot talk more about these projects, but this is how I work. And whenever the project is over, I just delete it. That's it. If I want it, I will save it forever, but if I don't want it, I can delete it. For example, this one, let's say this is a dummy project that I'm creating. Maybe after the project is created, once I'm satisfied with the results, I might potentially delete that. So let's get started with a project. So if you click on a project, let's say here is something that you need to name your project. Let's say churn prediction. Okay, and I will write it down as, let's say, keep it like this, churn prediction. Now there are multiple things that you need to add here. First of all, it's asking you to start a conversation in the project. Well, I can write down few things, but even if you want to write down something which is generated by AI model, then what you can do is you can quickly open a new chat and ask, this is what I'm trying to do, can you tell me how to start a conversation? The bot will also be able to tell you that. So everything can be done using AI, right? Even prompt engineering, if you want to write a prompt for something, you can also ask ChatGPT or Grok, this is what I need to do, can you help me write a prompt? And then once you get the prompt, you can use that prompt to get a better result. So that can also be done, right? So there are multiple things here: start a project, start a conversation, instructions, attachments. So attachment is very simple. I just need to attach this particular file, right, which is wa_fn. So let's try to attach that first. So this is the file. I'm going to attach it, and attachment is done, but I don't know what to add here and what to add here. So I will be taking the help of another Grok chat window. So let's say here I'm going to ask, let's say I'm going to ask in a very simple layman's term, when creating a new project on grok.com, what should we mention in the box start a conversation in the project, and what project instructions to provide? Let me give you some context. I will be uploading a CSV file in the project and would need to eventually create a machine learning model, like a classification model, uh, on customer churn data set So I need to interact with the bot, upload the CSV file, and ask questions accordingly. You need to behave as a ML expert, or you can also give this here, but this is also fine, right? Maybe what we can do is we'll shuffle this up so that first is the context that we are providing, and this is what we need to do, and then I will post it. I'm not going to provide this exact prompt as a deliverable of this course, but I think you can type it out while I am doing all these exercises, right? So you can see the only drawback with Grok is sometimes it gives you unnecessarily too long output, but I think I love it. So here, starting a conversation, suggested prompt for starting a conversation. I'll just try to copy it, go here and paste it. That's it. And then instructions. You can also check why this prompt. It has clarity, structure, actionable, technical. These are the project instructions. Copy them and add it up. That's it. Okay. Save. Anything else to take care of? Done. So let's try to create. Okay. Um, let's see what Grok is responding. I've received the uploaded CSV file. Wow, you have the entire piece of code. Okay, let me first go through it line by line, and then obviously we'll go through this code. Okay, so let me validate the instructions. I am starting a machine learning project to build a classification model for predicting customer churn using a CSV dataset. I will upload, which is correct. I have uploaded the file. The dataset contains customer information such as demographic. This is also correct. Indicating churn, example 1 for churn, 0 for no churn. This is also correct. You are providing as much information as you can. I need assistance with the following: loading and exploring the uploaded CSV, performing exploration of data, identifying patterns, pre-processing the data, including handling missing values, encoding categorical variables, and addressing class imbalance issues, suggesting and implementing a suitable classification algorithm, da da da, and evaluating its performance using. Okay, so this is where I need to change because we have not studied about a lot of algorithms. We have just studied about KNN classification model, but once you get started with KNN classification model, you can quickly jump over to other models as well with a simple line of code change. That's it. And providing code snippets, this is good. So this is what we need. Maybe what I'll try to do is implement the ML model using KNN classifier. That's it. Because we have not talked about any other classification models, I'm just going to stick to KNN classification model. That's it. So this is what the new code is. One more thing also to add is whenever you are doing vibe coding, you cannot, I mean, this is dicey to talk about, but I usually recommend people not to follow tools like ChatGPT or Grok blindly, right? You you can only use these tools as a coding help. So this tool is helping you to code. This tool is not going to teach you something, right? So never 100% rely on these codes, right? So that is the only thing you need to take care of. Now let me go through the code and I'll tell you what flaws this code has. It has read the file, displaying the basic information, which is correct, exploration of data, which is also correct, categorical columns. Okay, there is a small change or small problem that we have already identified. So what it is doing is it is by default checking the normal data frame. It is not checking whether any of the columns are of different data types. If you remember, in the last video we talked about total charges, right? Total charges was, maybe I'll try to show it here directly. If I do info, you can basically see that total charges is an object type. But if you look at the data, right, total charges is a numerical attribute. And as I know this data set, I know that this particular column is basically having some missing values. Okay, so that is what the problem is here. It has just checked the data frame, it has not checked individual column data types, and it has not changed them, right? So this is the first problem. The second problem is, I think all good. Here they have provided some EDA. Okay, so I'm just going to reprompt it because we want to do whatever we have done so far, right? Can you please, okay, let's not write please and all, which um, the creators of OpenAI has requested not to use such words because it increases their memory and all those things. So let's stick to very pure, a good prompt. Whatever we have done so far, I'm just going to prompt that and take that code. Okay, I don't want to perform EDA or plot any graphs, nor do I need smart or any other class imbalancing steps. I just need to read the file as df, change the data type of total charges to numeric, handle the missing values of total charges, and then perform one hot encoding and standardize the data, and finally create a KNN classification model and print me the classification report. That's it. So very clear statements. I just need this, right? So here it has created pipeline and all, which is not needed. I don't want to implement pipeline. Can you restructure the code, or can you rewrite the code? Okay, this is good. Very simple piece of code. um, some of them are a little bit questionable, but it's okay. I'll try to copy this, and then I'm going to go to my Google Colab, and here I'm going to paste it up. So let's try to go through this piece of code. Okay, let me try to write down vibe coding, and I will also make it bold. That's it. I have all the libraries, so everybody knows that sklearn is scikit learning, where you have train, test, split, you have standard scaler, one hot encoder, multiple things. Here I'm reading the file, very simple. Here is when I am changing the total charges from object to numeric. Categorical columns df.select, okay. We are dropping customer ID and churn. Numerical columns are including this and this to list. Then I'm doing a handling missing values in numerical columns. Strategy is median. You can use mean, median, whatever you want to. And then I'm imputing it. Then I'm handling missing values in categorical columns. So eventually there are no numeric missing values in the categorical column. So this piece of code is not that important. And then I have converted the data into one hot encoding, and then I have dropped categorical columns. So pretty much this is good. X is customer ID and churn is this and this. I think all good. And okay, I will stick to 0.25, whatever we have done in the previous class. And then standard scalar, all good. Fit transform and transform. For those who don't know about fit transform and transform, just try to go through the previous video or the previous lectures, you will understand. Then we have the KNN classifier and then the predict. I think all good. Let's try to run this. If there is an error, of course, we will be again going back and we'll try to ask, right? So there is an error, no such file. Okay, I will just try to copy this path and I will try to paste it. That's it. Okay, you can see the results are here, right? The classification report is this. We can also do a simple printing the accuracy score, and just need to okay. So accuracy score is 176%, which is not bad. Now if you deep dive into this classification report, so this is my personal favorite. I usually print classification report because it gives you like a detailed analysis of everything. So it gives you precision, recall and F1 score also support for both the classes. And you can see for class 0 the values are really good. For class 1 the values are little bit worrisome, and the reason behind that is, I can tell you the reason. You can also go to the chat to ask the reason, right? You, let's say for class 1 the recall precision in classification report is around 0.57. Why is that so? Let's try to ask Grok. The reason is very simple. The reason is the distribution of y variable. If you go to this particular column, you will be able to see that the distribution is bit off, right? If you divide it with the length of data frame and multiply it with 100, you will see that the distribution is 73 inclined towards no and 26% is inclined towards yes, right? That basically means your model sees more of these records than these records. And what does that mean? Imagine a baby, a newborn baby is getting to know about cats and dogs, right? The baby sees more cats, let's say 1,000 cats over the period of 4 to 5 months, and let's say 200 dogs. So the baby's memory has more cats information than dogs. Now if the baby sees a tiger which the baby has never seen in the past, potentially the baby will not be able to identify the tiger, and that's because tiger's images are not inside baby's brain. As simple as that. The more data you train, the more understanding the model will have, right? So how to fix this problem? The problem can be fixed by reshuffling the data, by upsampling, downsampling. So basically we call it as class imbalanced issue, which we can solve using SMART and various other things, which is out of syllabus for this particular program. If you want to get into this, you want to solve these problems of balancing out and various other things, you want to take this accuracy from 76 to 90, you need to learn a lot about feature engineering, hyperparameter optimization, etc., etc. And that basically comes under the career path of machine learning. Eventually, as a data scientist or as an AI engineer, if you are switching your career, then you can go ahead with that. You have to study a lot about these things. So, building a classification model takes 5 to 10 minutes, but to build the best model takes a lot of time, right? So but you can leverage ChatGPT to get to the next part even without learning more about machine learning. But let's try to see what ChatGPT is telling, or what Grok is telling. Indicating moderate performance in identifying positive cases. Below I'll explain. Okay, it has not quite understood what I wrote. uh, I basically wrote, why do I have a low recall precision for class 1? It has identified in general recall precision. Okay. Okay, what it is, telco typically has a class. Okay, it is able to tell with fewer churned customers class 1 compared to churned class 074. Since you opted not to use SMART or other imbalance in handling, the KNN model may prioritize the majority class, leading to lower recall and precision. So it's giving you some results here to perform some sort of okay. Can we use SMART to improve the accuracy? Let's try to see, and we should be able to take this piece of code, class. Okay. So the code is ready. I will try to copy this, take it here, paste it up, and then let me go to the code as well. Where did he? Oh, okay, here is when the smart is done. Okay, let's wait. It's taking a little bit more time as expected, but okay, it's because the grid search. Okay, so that's what I told you, right? In order to work on the final model, there are a lot of improvements that can be done. Improvements can be done on feature engineering side. Improvements can be done on doing balancing out. Improvements can be done on hyperparameter optimization. There are a lot of things you can see. Now the results are again not that great, but it has improved. The recall has improved. Precision has gone little bit down. Let me try to check the accuracy. Accuracy has gone down. Okay, so that means smart is not working. Now in this case you'll have to try something else. Smart ENN, various other things are there, but again, as I told you, that's beyond the scope of this predictive analytics part. That is it. In case you have any follow-up questions on this data set or any of the steps you're not able to understand, you can use this chat to ask anything. And let's say you go back and you want to go back to Grok on the same project, you can simply go to churn prediction and directly go to this conversation. That's it. And once you are in this conversation, you can ask back whatever questions you have. That's all about it. So using KNN classifier, I'm trying to remove this piece of code. In case you want, you can generate it out. As I told you, it's not in scope, so I'm deleting it. So our KNN classification model is done. 76.54% of accuracy, not bad. 57, 54, 56 precision recall and F1 score for the minority class, which is also not pretty bad. It's fine. Let's jump into the next classification model and let's try to code it out. Similar to a KNN algorithm, we also have a small use case or a small example talking about decision trees. So this is the example where I have multiple columns like age, competition, type, and profit. And I have different attributes like for old age competition, yes, type software, the profit is down. That means there is a loss. Profit or loss, it will be down, means loss. For age old competition, no software, it's loss. For given certain conditions, we are having a class called as whether there is a profit or a loss, whether the profit is up or down. And that is what we need to predict. The problem statement here is to find for a given entity or for a given new transaction whether there will be profit or loss. As simple as that. So my class attribute is very simple. My y variable is profit or loss column. And my x variables are all this age, competition, and time. I have only taken three variables just for the sake of simplicity because our ultimate goal is to identify the root node. How decision tree algorithms internally works to create your root node, right? So let's try to go ahead and understand this. Now there will be some mathematical uh, application, like there will be some mathematics I will be covering, but if it is little bit difficult for you, then it is completely okay to skip this part and directly jump into the Python code. When it comes to the Python implementation, the practical implementation of predictive analytics, it is super simple. We can implement a decision tree algorithm Python code in just few minutes. So first of all, I'll try to have a paintbrush in parallel. Let me move it to here and move these to here. Okay. Now, the first, as I told you, decision trees, there are two techniques. One is entropy and one is Gini. We will be using the entropy technique. Based on entropy, we will be trying to find which of them is the root node. That means which feature is most important. Okay. Now in this case, how many profits we have? 5 profits. How many losses we have? 5 losses. So the first formula is entropy is minus P by P plus N log of P by P plus N minus N by P plus N log of N by P plus N. So what will be my P? My positive cases by 10 log of 1 by 2 minus 5 by 10 log of 1 by 2. If I combine all of them, it will be minus 1 log of 1 by 2, which is going to be 1. If you calculate this, log of 0.5, it will be giving you -1. Log of 0.5 is going to give you, so this is a log base 10. Oh, log of base 2. My bad. Log of base 2. Okay. This is approximately -1. So log of base 2. This is base 2. So -1 into -1 will be 1. So my entropy is basically my 1. There is a formula, gain is equals to class entropy minus my normal entropy. This is my class entropy. Okay. Now I will try to first use my age column. In age, how many old do we have? We have 3 old. How many positive and how many negative? All are negative. So 0 positive, 3 negative. For mid, 2 positive, 2 negative. For new, 3 positive, all negative. Okay. Now I will be calculating the entropy here, PINI. Now information gain for this will be 0. If one of them is 0, then the information gain will be 0. For this also will be 0. Okay. And for this, it will be calculated using this same formula. So I will try to calculate in this small box. So -2 by 4 log base 2, 2 by 4, -2 by 4 log base 2, 2 by 4, and it's ultimately going to be 1. I will write down it as 1, 0 and 0. Another formula is entropy of age, which is my this part. Okay. Entropy of age formula is summation of Pi plus Ni by P plus N multiplied with I of Pi Ni, which becomes, in the first case, my I part is 0 and 0, right? So first case will be 0 plus 3 by 5 plus 5 into 0 plus 2 plus 2 by 5 plus 5 into 1 plus 3 plus 0 by 5 plus 5 into 0. Cancel, cancel. This becomes 4 by 10, which becomes 0.4. So what will be my gain of age? My gain of age will be 1 minus 0.4, which is 0.6. Now this is very important, right? Similarly, I will do it for competition. Yes and no. How many yeses? Pi, Ni and I. How many yeses? Yes, profit. No, loss, 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 up. 1, 3, 4, 2. What will be the I here? -1 by 4 log base 2 1 by 4 minus 3 by 4 log base 2 3 by 4, which will be, what is log base 2 1 by 4? Log base 2 0.25 is -2. So minus 1.4 into -2 minus 3 by 4 into log base 2 of 0.75 is 0.75 is minus 0.41. Minus 0.41. So if I calculate it, it will be 2 minus 1 by 2 0.5 minus 3 by 4, 3 into 0.41 divided by 4 is this, plus 0.5 is whatever it is, 0.8. Okay, so this becomes my 0.8. Got it? Similarly, I will calculate it for this. Minus 4 by 6 log base 2 4 by 6 minus 2 by 6 log base to 2 by 6. Log base to 4 by 6, which is minus 2 by 3 log base to 0.66 minus 1 by 3 log base to 1 by 3, which is 0.33. So log base 2 of 0.66 is minus 0.6 minus 0.6, and for 33 is minus 1.6 minus 1.6. So this will be 1 by 3 multiplied with this minus, sorry, 2 by 3 minus 1 by 3 multiplied with this. 2 by 3, 2 by 3, 0.2, 0.4 minus plus 1 by 3, 1.6, 0.5, around 0.9. So this becomes 0.9. So once this becomes 0.9, what we need to do next? We need to calculate this thing. So what will be my entropy of competition? Summation of Pi plus Ni. So 1 plus 3 by 10 multiplied with 0.8 plus 4 plus 2 by 10 multiplied with 0.9, which will be 0.4 into 0.8, 0.32 plus 0.6 into 0.9, 0.54, which is 0.86. And what will be the gain of competition? 1 minus 0.86, which is 0.14. So 0.14, 0.13, whatever it is, right? Now for age, I got my gain as 0.6, and for competition it is this. Obviously age is having more gain, so age is an important feature than competition. I will be doing the same thing for the last attribute, which is my type. So for type, software, down, 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 up, up, up. So down, sorry, not down. Software, hardware, PI, NI, I. So this will be 3322, right? So if it is 33, I will be 11, right? It will use the same formula. What will be the entropy of type? Entropy of type will be 3 plus 3 by 10 into 1 plus 2 plus 2, 4 by 10 into 1, which is going to be 1. So what will my gain? My gain will be 0. Now out of age, type and competition, which of them is having the highest gain? It is definitely age. So age becomes my top node. Age becomes my root node. What comes next? Will it be competition? Will it be type? Now for competition the gain is 0.14. For type the gain is 0. But you cannot simply say that competition is better than type. Our next step will be for only for age attribute. Only for the age attribute. For old, mid and new, there will be three rows: old, mid and new. Only for old values, you will again be calculating the entropy for competition and type. For mid, you will again be calculating for competition and type. For new, you will be again be calculating. So the process goes on. So for mid, type could be an important one. For this, competition could be important. For this, competition could be important. And that's how you go ahead and build your decision tree. So even for a small example, you can see how difficult it is to mathematically calculate who is the best lead, who is the best node, and how the decision trees are calculated. But when it comes to the practical applications part, it is super simple. You just have to call your decision tree classifier and then done. You will be able to get all the outputs. So that's all about decision trees classifier as an example. Uh, as I told you again, that if mathematics is little bit difficult for you, either you practice or you probably skip it for the next part. Go ahead and implement it practically. So in the next video, we shall be jumping into one of the use cases where we will be implementing decision tree classifier, very similar to the one we did for KNN. Hi, welcome to this video on decision trees. We all studied about decision trees. Before that, we studied about KNN. While we were preparing the code for KNN, our almost 90% of our work is done. We are just going to reuse the code to implement for the decision tree classifier. So I'll again run these all steps. So I'll try to restart my runtime because my kernel might have died. So I'm just restarting it. So we'll get started with the first thing, which is mounting the Google Drive, which was I'm importing all the libraries and reading the file. So that's how my dataset looks like. Dataset.information. If you closely look at all these things, I have been using this dataset for quite a long time. So I know that there is a mistake here, which is total charges, which is a numerical attribute, but it is showing as object. So I need to convert it into numericals. So I have converted into numericals using toNumeric. And then when I am running the information, you can see there are 11 null records. Now 11 null records can easily be treated, but again, you have to check which technique is best and all those things. So I have just ignored these 11 records because 11 records out of 7043 is almost 0.15%, which is very low. Okay, so I have dropped this, and again I am printing my head. My churn distribution is something like this. That means 73% of the customers are active, 27% churn rate. That means as a data scientist, if you are joining a company or as a data analyst, you have been told to create predictive model in order to predict for a new customer. In that case, your main aim is to bring this number down. How can we bring this number down? If we are able to predict a customer is going to be churned or not, accordingly, we can provide them some offers to retain them. Done? So next step was to divide the data into X and Y. Y basically means your churn, which is your dependent variable, and X are all my independent variables. And then I am converting the categorical features into numericals by doing feature encoding, especially dummy encoding. Run this and then run this. And then I am splitting the data into training and test. So if I draw my architecture once again, let's say this is my data. 73% of active customers, 27% of churn customers. What we did was we did some minute EDA and we kind of cleaned the data. After that, what we did was we divided the data into training and test. Training and test. After that, what we need to do is we need to perform some feature scaling technique. After feature scaling, there is a step called as feature engineering, but we have not studied about this, so I'm going to skip the feature engineering part. Once that is done, you have to create multiple models, model 1, model 2, and so on, model n. So your training data, like after your feature scaling and feature engineering, ultimately will also have your scaled training and testing data, right? So your training data will be used for training and testing data for testing. And then once you get the predictions, let's say this is giving 82, 80, and 75. This will be treated as the best model, and then further some other hyperparameter optimization or feature engineering steps will be performed to boost this accuracy to 90 or 95%, and then our model is ready for deployment. That is the end-to-end scenario. Now our model 1 is already done, which is my KNN. Now we are preparing the decision tree. So I will split my data, standard scaler, my scaled values. I will not run my KNN classifier, but I will copy paste the code and I will go ahead and create my decision tree classifier. And then I will again copy paste some other codes, which is my predict function. And I think that's it. And last but not the least, to check the accuracy. Okay. Now I have copy pasted everything. What we need to change here is the classifier name. That's it. Now decision tree is basically present inside sklearn.tree. But if you don't remember, simply do sklearn decision tree classifier and you will be able to check the documentation about decision tree classifier. There are so many arguments in this decision tree classifier and all these are hyperparameters. By default the criterion is Gini. By default the splitter is best. By default max depth is none, and all these features are there. You have to perform hyperparameter optimization in order to get the best version of your decision tree. But we will be using the basic one. So I'll be making it model 2 or model underscore dt, model underscore dt, and done. Now my classifier is ready. I will be calling ypred underscore dt, model underscore dt to predict on my testing data. And once that is done, I will pass my ypred underscore dt and I will print my accuracy. My accuracy is 72%, which is bad. Definitely this is bad as compared to KNN. If I go back to the model, you can see this accuracy was 75. Now this is 72. Again, if you want to do the same steps for the out of the box prediction, you can do it, but I will not repeat it as we have already done for KNN. The same thing you can do it for decision tree classifiers. Now, I know some techniques to quickly enhance the classifiers accuracy by doing some minor changes, but I will keep that to you so that you can learn hyperparameter optimization later on, and then you can try it out by yourself. So that's all about this particular video on the decision tree classifier implementation. And similarly, any classifier you want to implement, let's say be it a SVM classifier or a naive based classifier, you just have to copy paste these codes. Let's say you want to implement SVM classifier, simply type sklearn SVM. You will be able to redirect it to their official documentation, import them, initiate this classifier, and everything is same. So that's all about decision tree classifier. In the next video we shall be talking about random forest, and further we will be talking about the random forest implementation. And once random forest is done, we will also compare all these models in order to decide what's our next step. Hi, welcome back. In the previous vibe coding session, we had created till the KNN classification model. Now let's jump into implementing the decision tree model, decision tree classification. Okay, let me also write down KNN classification model here. Vibe coding. KNN classification. Okay, and let's say I will copy this part here and okay, done. And we had run this code last time, and then the results were 76% for KNN classification model. Now let's try to jump into decision tree classification model. Now, as we have already done some sort of smart related chat, now this model, I mean, Grok already knows the context of the oversampling and the downsampling problem that we faced because of which the recall and precision was on the lower side. So in order to not take into the account, what I want is I want to paste the entire code right away. Can you simply change the KNN classification model to decision tree model? It's very simple. I could have done it just one line of change. Instead of KNN classification model, you just simply have to, let me try to copy paste it, decision tree classification, and then that's it. And then I will try to copy this piece of code, and then I will copy this piece of code, dt dt dt, and then let's try to make it ypred underscore dt. Just change kn to dt, that's it. And change here dt classification classifier classification report, ypred dt, and then here dt classifier classification report ypred dt. That's it. If you run this piece of code, you will be able to run your decision tree classifier. But let's try to check what it has done. You can see everything is same till here, and it has directly worked on this part, right? So that's it, very simple. Now if you can also compare the results, the decision tree classifier is again little bit worse than Karen classification model. So you can see the majority class results have also deteriorated, minority class results have also deteriorated, accuracy has also deteriorated from 76 to 72. Okay, but this is what it is. Again, if you want to improvise, I just don't want to repeat all those things again and again. There are thousand ways of improving it, which is not in the scope of predictive analytics. In predictive analytics, we only focus on what are the capabilities of predictive analytics, how do we get started with predictions, predictive AI part. But eventually, if you want to get into this machine learning field, there's a lot of things that you need to study, right? So that's all about it for decision tree classification. In the next vibe coding session, we will be jumping into random forest. In this video, we shall be focusing on random forest, our next classification algorithm, and one of the most important algorithm in the field of classification. Random forest. What do you mean by random forest? We all know what a forest is. A forest is nothing but a combination of trees. So the similar concept is also used here. Here forest is nothing but a combination of trees. And what are these trees? These trees are decision trees. What do you mean by random? Randomness is basically, I will explain you what exactly and how exactly random forests are created, and then I will explain you what is the random part here. So random forests or random decision forests are an ensemble learning method. Ensemble here means it's a hybrid learning model for classification, regression, and other tasks that operates by constructing a multitude of decision trees at training time. For classification tasks, the output of the random forest is the class selected by most trees. So I'll try to explain it using a small example. Imagine you have a data set. I'll talk about the same churn prediction. List of 10,000 customers, out of them 2,000 churners and 8,000 active. So usually what happens is you divide it into training and test data. And on the training data, you create your models. And once the model is done, you pass the testing data to finally get the predictions. That's how it works, right? Now, what happens in random forest is, same example, 10,000 records, 2,000 churn, and 8,000 active. You do the same thing. You create your training data and testing data. Let's say your training data has 8,000 records. Let's say out of them, 6,400 are active and 1,600 are churned. And here again, 2,000 records, around 1,600 active and around 400 churned. Now, random forest, as we know, is nothing but a combination of trees. So what happens is it creates multiple trees: tree 1, tree 2, tree 3, tree 4, dot dot dot, tree n. So multiple trees are created. How do we decide how many trees to create? When you call the random forest classifier, there is an argument called as an estimators. By default, this value is 100. Once we jump into the practicals, I will explain you this thing again. By default, the n estimators are 100, which means by default, if you create a random forest, 100 decision trees will be internally created. Just that is understood. That is the forest part. Forest is combination of trees. What is random here? So what happens is whenever these decision trees are created, randomly data points are being passed for training. Which means if your training data is 8,000, all the 8,000 records will not go into all the trees. Let's say 2,000 record goes here, 1,500 goes here, 1,200 goes here, 5,000 goes here, 2,000 goes here. So the data points that goes into multiple trees are random in nature. That is the first randomness behavior. Another randomness behavior is inside this 10,000 records. Let's say there are 20 features. That means 20 x variables. That is also random in nature. Maybe here you pass 5 features, here you pass 4 features, here you pass 18 features, here you pass 3 features, and so on. So the number of data points that goes to a tree and the number of features both are randomly distributed. And each of this decision tree is nothing but a weak learner. They are a weak learner because they are fed up with less amount of data points and less features. So they are called as weak learners. And ultimately these weak learners are created. And finally, once they are created, you pass the testing data for predictions. They do some predictions, 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 and predictions. And finally, you take voting out of it. That means, for an example, one of the customers' data is passed. This tree predicted as active, active, churned, churned, dot 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 churned. So there are more voters for churned. So our final output will be this customer is likely to be churned as per this random forest. And that is one of the reasons why random forests are very powerful, at least as compared to decision trees. And in 90% of the cases, random forest outperforms as compared to decision trees. There are still certain cases where decision trees could be better, but most of the cases we see random forest performing better. So same thing has been depicted in this example also. You have data set, you divide the data set into multiple features, and when you divide it into multiple features, repetitions are allowed, and you create multiple decision tree. So for this decision tree, probably age could be an important factor. For this decision tree, probably salary is the most important factor. So all these decision trees that are created that are unique and important, and all these importance are accumulated and voting is taken, and that's why random forest ends up being the best classifier. In the last video about decision tree classifier, we saw how we copied the code from the 𝐶𝐢𝐦𝐞𝐋𝐢𝐧𝐞 classifier and implemented the decision tree classifier. So I'm going to do the same thing for random forest classifier as well. We all know about random forest, random and forest, what the random part is all about, what the forest part is all about. So let's try to implement the random forest classifier. So I'll quickly run all these codes again. I'm simply blindly going to follow and run all the codes. That's it. And once we are done with all the codes, then we will start implementing the random forest classifier. Okay, everything is done. Now opening back my paintbrush that we used for the decision tree classifier thing. I hope everybody is clear about the architecture. We have data, we know the data's distribution, we perform some EDA steps to clean the data. Let's say null value imputation or any kind of redundant information is there, we have to get rid of them. Then we divide the data into training and test. Then we perform some feature scaling technique so that our data are scaled, so that the data is not biased to the model. Then we perform some feature engineering, which we didn't perform in our existing piece of code because feature engineering is an advanced topic that we are not covering here. So let me ignore this. So after the scaled values, the scaled training and the scaled testing data, you are using it to create the models. So our model 1, which was KNN, was giving us 75% accuracy and decision tree was giving 72% accuracy. Now I am going to create model 3, which is a random forest model, and we'll see what is the accuracy of random forest. So I will quickly implement my random forest classifier. I'll copy paste the code. So that's the beauty of writing Python code. So you can simply create your first predictive model in just few lines of code. So instead of this, I will use my random forest classifier, but my random forest classifier is present inside ensemble. Again, as I told, no need to remember all these things. Simply search random forest classifier and you will be able to get all the details. All these are different parameters in random forest classifier, and this is the most important parameter. By default, there are 100 trees. But if you increase the number of trees, obviously the accuracy will increase. So we'll go ahead, initiate this. I'll mark it as model underscore RF, model underscore RF. Everything else remains the same. My random forest classifier is ready. My predictions will be run on my model underscore RF. And based on the predictions, I will be printing the score and my accuracy is 79%. So if I go back here, I will note down my accuracy is 79%. So let me just rerun this code with some high amount of estimators. I'll rerun this code. Accuracy has decreased. That means the best number of trees are definitely between 100 and 500. 79. Okay, let it be. So I have got 75 using KNN, 72 using random decision tree, and 79 using random forest. Your next step is to keep trying multiple other algorithms, and once your hit and trial process is done using multiple algorithms, your next step is to choose one or two or three best performing algorithms and go ahead and perform this hyperparameter optimization step. So implementing your first classifier is very simple, and that's how we implement our random forest classifier, which is present inside your sklearn.ensemble. So I'll quickly change this text to random forest classifier, and same for decision tree also, DT classifier. So that's it. See you in the next video. Hi, welcome back. So in the previous video, we ran till decision tree classification model. Let's try to copy this as our next task is jumping into the random forest classification model. So I'll try to copy paste it, right? You can always use AI. Let's say, can you change it to random forest classifier? Just write the last few lines of code, no need to repeat everything. Okay, I just told not to repeat everything because unnecessarily a lot of tokens are being used. So you can see I will just copy this. The last few lines are basically this, right? One more thing is, which is your import statement. Now I know it is basically inside ensemble, but let me also ask how to import. Just give a one liner. It's basically from the ensemble technique, or so the ensemble method. So sklearn dot ensemble, and here you just have to add random forest. That's it, and not add random seed and all those things, and everything else should be okay. And estimators is basically number of trees. Let's say I'm providing as 500. Training data and doing the prediction. Okay, for the sake of having different variable names, I'm just changing it, but it's not super mandatory. Everything is good. Let's run this. Okay, you can see the results are little bit better than Canaan and decision tree. I will try to copy and paste the classification report. Sorry, the accuracy. Random forest classifier. 72 is the accuracy, but overall I would say that these are better results. Your majority class results deterioration is completely fine, but minority class precision has gone up, which is a good thing, and recall is has gone down, but it's okay. Overall I think it's a good progress. Similarly, you can also try out different other classification models. There are like more than so many. There are like 20, 25 models, right? KNN classification, naive based classification, decision tree, bagged classifier, random forest. And there are multiple ensemble techniques like ADA boost, XG boost, GB boost, many other things, right? So give it a try and see you in the next video. In this video, we shall be talking about another concept called as boosting. Before getting into boosting, let me quickly talk about ensemble learning. Ensemble learning is a technique where one of your algorithm or multiple of your algorithms starts failing. Now imagine you have a KNN classifier. It is giving you 65% accuracy. Your decision trees are giving you 70% accuracy, and some other algorithm, let's say SVM, is giving you 71% accuracy. No matter what you try, these algorithms are not giving you more than 80 or 85% accuracies. What if you combine each one of them to create a final classifier? Let's say you can name it as a superhero classifier. What internally does is, whenever for a new data point, all of these algorithms will be predicting. Let's say this algorithm predicts this as class A, this as class A, and this as class B, and you finally take a voting out of it and you predict it as A. So this is a hybrid classifier. And somehow you must be remembering that we also covered random forest, which also works on this principle. Inside random forest, your small classifiers are different decision trees, right? So random forest is also one of the ensemble learning technique. Inside ensemble learning technique, we have two concepts. One is called as bagging. This is an example of bagging. Random forest is an example of bagging. Another concept is boosting. Now how does boosting works? Boosting is little bit different from bagging. Bagging, you have a data point, you divide it into training and test samples, then you create small classifiers, you fed them with little bit of data, repetitions are allowed, and those classifiers are created. They predict on your testing data, and you take the voting out of it. That is all about bagging. Bagging is important, boosting is also important. Let's try to cover boosting in this particular slide. In this example, you can see I have a data set. Let's say I have 10,000 records. I divide it into training and test data. Fine. Now, in bagging, what happens is from here you directly create multiple bags and you feed them with different types of data, and then you take the voting. In boosting, what happens is you create one bag, just one bag. You randomly populate data here. Let's say from 8,000 records, you populate 2,000 records. Repetitions allowed. You train them and you create a model. Then what happens is, if you have passed 2,000 records, then definitely there are 6,000 records that are not a part of this model. So you pass any of these data points here and test with the training data set. So let's say you pass 1,000 records or 2,000 or 3,000 records, and you see whichever data points are giving wrong predictions. Let's say 2,000 or 3,000 records are giving wrong predictions. Now these data points becomes a part of your second bag along with some new data points. And again it is trained, model is trained, again the unseen data will be tested, and this process goes on. So it is nothing but an iterative process of learning. I hope everybody is clear. You have your original data set, training data set, testing data set. Just forget about testing. We are not using it here. The first time your bag is created, you pass randomly 2,000 records. And let's say you created a model. So how many records are not passed here? 6,000 records. Let's say out of this 6,000 records, you are testing your first model with 1,000 records. Simple. Out of these 1,000 records, maybe 400 records are wrong prediction, 600 records are correctly predicted. Then what happens is, when you create your second bag, you randomly populate data points, let's say 2,000 or 3,000, and this 400 also goes here. So all total 3,400 records goes here. Again a model is created. All the unseen data that are not a part of this bag are tested, and this process goes on. It goes on and goes on and goes on till the time you finally get your final model. So how many algorithms do we study under boosting? There are multiple algorithms, starting from gradient boosting, gradient boost, extreme gradient boost, cat boost, ADA boost, and so on. Multiple boosting algorithms are there. XGBoost is, however, one of the best boosting algorithms, and it was one of those algorithms when it was launched. Almost every Kaggle competition winner was implementing this algorithm. It is that powerful. And so far till date also, XGBoost is one of the most important algorithms that we perform or that we study inside classification. XGBoost can also be used for regression, but again, as we are only talking about classification right now, I'll only be showing you the practical applications of XGBoost using the XGBoost classifier using a certain data set. Let's try to implement one of the boosting algorithms, one of the advanced ensemble learning algorithms. The use case and everything remains the same. This is the same churn prediction use case where we did some pre-processing steps, training and test sample split, and all those things, implementing KNN classifier, decision tree classifier, and random forest classifier. If you want to look at the architecture, this is how it is, right? Our KNN is giving us 75, decision tree 72, and random forest 79. Our next step is to perform a ensemble learning technique. Now, there are multiple types of, as we all know, ensemble learning is of two types, bagging and boosting. And one of the bagging algorithms we have already covered, which is random forest, right? Let's try to implement one of the boosting algorithms. There are multiple boosting algorithms, which starts with gradient boosting. We also have extreme gradient boosting, which is also called as XGBoost. We have ADA boost, we have cat boost, and so on, etc., etc. That means there are multiple other types of boosting algorithms also. We'll try to implement one of them. So I'll try to implement ADA boost. So I'll copy paste the codes from random forest classifier. Everything is same, only the classifier will change. That's it. So here I will implement ADA boost classifier. If you want to cross check, simply do something like this and you will be able to see it's the same sklearn ensemble and ADA boost classifier. Done. I will rename it to ADA boost classifier. I will initiate it model underscore ADA. I will call this ADA boost classifier. N estimators, let's make it 100. Model underscore ADA. Everything remains the same and my ADA boost classifier is ready with N estimators as 100. I will do the same predictions on my ADA boost model and my predictions are ready. Now I will print my accuracy. So I will pass my Y test and Y pred ADA and I will run this and you can see my accuracy is 80%. So what do we find? We find that the boosting algorithm is giving me 80%. So ADA boost is giving me 80% accuracy. Now, what are the next steps? The next steps are obviously to run multiple other models. I can at least name 20 to 30 classifiers. So, going through each and every classifier theoretically and practically won't be possible. So, if you want to take this exercise to the next step, go ahead and implement multiple other algorithms. We already implemented KNN, decision tree, random forest, and ADA. What you can perform is SVMs, naive Bayes classifiers, logistic regression, extra trees classifier, bagged decision trees, all the different three types of boosting technique, XGBoost, normal gradient boosting, cat boost, and so on. Just go ahead and implement all these algorithms and then you compare the accuracies of each one of them. And then the next step is to choose one, two, or the three most performing models and go ahead and perform the hyperparameter optimization. So that's all about this particular video on ensemble learning. I hope you understood the end-to-end model building steps, end-to-end architecture on how a predictive model is actually created, executed, and run. And theoretically, you know what could be the next steps and how to deploy it. Deployment obviously needs the expertise of data engineers in real-time scenarios, not required for data analysts and data scientists. But I hope everybody is clear with the entire flow. That's all about this particular video, and this is where we wrap up classification. Hi, welcome back to the vibe coding session. We will jump into the next part, which is ensemble techniques. So theoretically, what is ensemble techniques? Ensemble techniques, so you can call it as ensemble, ensemble, whatever you want to, but eventually ensemble techniques are hybrid techniques, right? Where your individual classification model fails, ensemble learning comes into picture, right? There are two types, bagging and boosting. I need not have to cover them once again. Let's try to take help of Croc to code the last few lines of code for multiple ensemble learning. Uh, can we also implement some ensemble learning models such as AdaBoost, CatBoost, XGBoost, etc. and just write down the last few lines of code along with import statement. So let's try to implement AdaBoost, CatBoost and XGBoost. You can see first of all it has already provided me all the why it's failing. CatBoost is failing. CatBoost is also a part of sklearn if I'm not wrong, but let me try it out. CatBoost classifier. Okay, no problem. Let me try to. I thought CatBoost is also available inside sklearn, but it's okay. We will try to install it and then import it. Okay, it's running. Let's give a couple of minutes. In the meanwhile, let me jump into Grok and check the code. Code for ensemble methods for AdaBoost. It has, yeah, see, it's pretty straightforward. You are just changing the model name, that's it. And in most of the cases, nothing else, right? You are still using the xtrain, ytrain as fit, then predicting the xtest. That's it. You're just changing the model name. Now I'll rerun the command and then I will take my first piece of code, which is Ada classifier, and try to see. Ada classifier has done like this. Maybe we can also print the accuracy score. Accuracy score is 80%. Very, very good, right? So better, far better than our traditional algorithms. Let's try to go for CatBoost. I will also print the accuracy. I'm assuming that XGBoost will give us a little bit better results than all of these models, but that's just an assumption. Sometimes very basic models can also give you better results, and the more complex ones might not, which is fine. And let's try to run XGBoost, and here we go. XGB classifier. Okay, so AdaBoost has given us the best results, 80%. Can we move from 80 to 90? Of course, the answer is yes. By spending some time with this use case, you can definitely reach from 80 to 90. 80 to 85 for sure, but to reach from 85 to 90 is when the challenge will start. More than accuracy, your challenge should be improvising the precision recall and F1 score for the minority class. But once you balance it out, I think you will be able to solve it, right? So that's all about vibe coding for classification. I think we have covered most of the things. In case you have a very specific use case where you want to get started with classification models, you can do the same techniques that I have explained just after the KNN videos on how to get started with project workspace and other things. Set it up and start chatting with AI and do vibe coding. See you in the next video. The next type of technique or next type of problem that we study under supervised learning is basically regression. What do you mean by regression? We are all clear with classification and we will be learning about regression. Regression analysis is a statistical method to model the relationship between a dependent target and independent variables with one or more independent variables. More specifically, regression analysis helps us to understand how the value of the dependent variable is changing corresponding to an independent variable when other independent variables are held fixed. It predicts continuous or real values such as temperature, age, salary, price, etc. So one of the examples I will talk and explain is, let's say I have multiple records for area and price. For 500 square foot, let's say the price is 2 million. For 1000 square foot, let's say the price is 5 million. For 1200 square foot, let's say the price is 6 million. For 700 square foot, let's say the price is 3 million, and so on. The question here is, what will be the price at 1500 square foot? That is the question. What we need to do here is, we need to predict price. The price is my y variable based on my area x. So if I draw my graph based on my area and price, let's say 502 million is somewhere here, 1005 million is somewhere here, 1206 million is somewhere here, 703 million is somewhere here. These are my multiple data points. How to find the relationship between price and area? I hope everybody remembers the formula of line is mx plus c, y equals to mx plus c, where m is nothing but your slope and c is nothing but your intercept or bias or constant, whatever you can say, right? Now, based on these data points, what we do is we come up with the best fit line that goes through these points. A line that is closest to these 4 data points. Let's say this line. There could be multiple lines. There could be millions of lines, right? But we need to find the line that is closest to the data points. Of course, there is a strategy to find. Let's say I'll talk about these three points. This is a line and another line is this. How do we find line 1 is better or line 2 is better? Of course, we have to see how far these data points are from each of these lines. This data point, I'll calculate the distance. Similarly, I will also calculate the distance from these data points to this line. Let's say this is distance 1, distance 2 and distance 3. So D1 plus D2 plus D3. And let's say this is distance 4, distance 5 and distance 6. Whether this is larger or this is larger. If this is larger, then L2 is discarded. L1 becomes my best fit line, right? We will again be using the concept of Euclidean distance to find the distance between 2 points, right? Using examples, I will be explaining in the next particular video in depth, but coming back to this example, if you are able to find this line, which is called as the best fit line, now you just have to find where your 1500 point is. Let's say your 1500 is somewhere here. So you take this and try to see where you are dissecting this line. This dissection is basically your predicted price. Let's say the predicted price is around 10 million. So this is what you do in the regression part. Based on multiple features, you predict your target variable. So in the next video, we shall be talking about different types of regression using examples, and further we will also jump into the practicals part to show you how regression can be performed on a given data set. Let's go ahead and implement our regression code. We have done the same thing. I'm using Google Colab and I have already mounted my Google Drive. My data set is in my Google Drive and this is the data set that I'm going to use, which is 50 underscore startup.csv. So I'll try to read the file and I'll show you how the file looks like. That's how the file looks like. I have R&D spend, administration spend, marketing spend, my state, and the profit. So what we need to do here is, let me explain the use case. We need to predict the profit given any kind of this information. So if I pass, my R&D spend is X, my administration is something, my marketing spend is something, and I stay in California, what will be the profit? That is the simple use case, and this is why we are going to implement regression code here, regression algorithms, because we are predicting on a continuous numerical variable. Now, of course, I cannot really show you the graph for this particular example, but as we are doing multiple features, we are using multiple features, that's why we will call it as a multiple linear regression problem. Imagine I'm going to do a profit prediction only based on R&D spend. That means my R&D spend will be on my x-axis and my profit will be on y-axis. Let's say for first one, 165 and 192, somewhere here. 162 and 191, somewhere here. 153 and 191, somewhere here. 144 and 182, somewhere here. 142 and 166, somewhere here. Now based on this, I will be creating my line, and if you ask me what will be the profit at 150k spend, R&D spend, probably here. So that will be my profit. Easy to visualize. Now this is a case of simple linear regression problem where you are only having one feature. R&D spend is your only feature, and based on that you are doing a prediction on profit. The formula here is y equals to mx plus c. But in this example, as we are having multiple features, 1, 2, 3, 4. There are 4 features, but inside state also there are multiple other variables, right? So let's say you want to do some label encoding, or you want to do some one-hot encoding. You can do one-hot encoding. Once you do one-hot encoding, let's say you will end up having 3 or 4 valid values or 3 or more dummy variables. So those many features will be treated. So we'll try to perform some feature encoding here. Sorry, yeah, we'll performing some feature encoding here. So let's say I will divide my x data into df.iloc dot values and y equals to df.iloc the last column -1 dot values. I'll run this. What is my x? My x is everything except my profit, and my y is my profit. My y is my profit. Now I will implement one hot encoder sklearn.compose import column transformer sklearn.preprocessing one hot encoder. In the classification part, we used get dummies, right? So that's another way of implementing dummy encoding or one hot encoding. Now this is another way of encoding. So you can use either of these techniques to perform encoding, right? CT equals to column transformer. So here my transformers encoder, one hot encoder, how many? 3, and then reminder equals to pass through. CT dot fit transform remainder. Done. Now if you want to print my x, that's how my x looks like. So three dummy variables are created, right? Now if you ask me what will be the formula of my multiple linear regression, the formula is very clear. 1 2 3 4 5 6 features. So y equals to m1 x1 plus m2 x2 plus m3 x3 dot 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 m6 x6 plus c. That's how my multiple linear regression problem looks like. And as we have so many features, it is impossible to plot a graph. So I'll not be able to show you a graph like this, as this is a multiple linear regression problem, but we will try to go ahead and create our model. Our next step is to do a training and test split. So if you want to ask me about the architecture, it somehow remains the same. We have data, we are dividing it into training and test. Again, we will be creating our multiple linear regression model, passing the training data. Using the testing data, we will be doing predictions. Simple, right? So x train, x test, y train, y test. I will be calling my train test split from sklearn.model selection import train test split. I'll be calling this, passing my x and y, test size equals to 0.25. Done. Then I'll be performing my feature scaling technique from sklearn.preprocessing import standard scaler sc equals to this, xtrain equals to sc dot fit transform. So fit transform is for my training data and only transform is for my testing data. All looks good. Fit transform for training and transform for test. Because we fit the training data for model building. Now I will call my model. Now exactly the similar way that we create classification model, you import your libraries decision tree classifier, initiate the classifier and fit the training data. Same here also. So from sklearn.linear model import linear regression, and then I will call my model equals to linear regression model.fit training data. Done. So my linear regression model is done. Our next step will be predicting the test results. So what we need to do, same fashion, ypred equals to model.predict testing data. And then your predictions are all captured here. Now, in the classification part, your prediction was nothing but your y variable. Let's say your y variable was churn column, whether it is churning or not. So your output was binary. But here your output will be a continuous numerical variable, right? It could be anything. And your actual data is something like this. Now let's try to plot the actual data and the testing data and see how far are they from each other. Plotting the testing versus prediction data. So I will be using plt.plot. First I will pass my testing data. I will mark it as blue color. I will make the label as test. Copy paste. Red predictions. plt.show run. And that's how your prediction versus test data looks like. Now, out of the box prediction. Let's say you want to do a prediction of out of the sample prediction. You want to do a prediction on a data set or a data point that is not a part of the data, right? So simply, let's say I want to have New York as my city. Let's say my R&D spend is 120K, my administration spend is again 120K, and my marketing spend is around 400K. So what we can do is df.head x. Okay, df.head 1. Yeah, R&D spend, and what was my x? Yeah, yeah, this is for R&D spend, this is for administration, this is for marketing. Correct. So given these conditions, I will try to create my data. 0.0, comma 1, 0.0, comma 1.0, comma 120K, comma 120K, comma 400K. That's my data, right? Now I will be passing this data to my data frame. So I will create a pandas data frame. So simply I will name it as new df equals to pd.data frame. I'll pass my data. Now, obviously, before passing the information, my data has to be transformed based on the training data. Based on my training X-train data, I have to transform this, right? So I'll pass my new df, and then I'll pass single equals to model.predict on new df, and then print single. So what is my single? So my profit is 152K. That is my profit. And that is all about regression. Now you simply have to, instead of all these features, imagine you just take one of them. Let's say this one, which is you can just simply drop it here itself. You drop all these columns and only keep one of them, and then try to predict for profit. That becomes your simple linear regression problem. And in that you will be easily be able to plot the graph and show your best fit line. But as we are implementing a multiple linear regression problem, multiple linear regression algorithm, we will not be able to plot that graph between features and your class distribution, or sorry, features and your y variable distribution. So that's all about regression, and that's all about out of box sample prediction as well using a regression code. In the next video, we shall be jumping into clustering, and further we will also be talking about clustering practicals and then various other topics. Hi, welcome back. The way we did our classification model vibe coding, we will be doing a regression model as well. In the previous video, you have seen that we have implemented a regression model, a linear regression model for one of the use cases. And in this video, we are going to take the same data set and we will be doing some vibe coding. To get started with, let's try to upload the file here. So the file was 50 startups if I was not wrong, and that's the file. I will try to rename it, or let it be, doesn't really matter a lot. Rename it 50 startups, right? Now we are going to leverage whatever we have done in classification. We are going to replicate it, not leverage, sorry, we are going to replicate that. And to replicate, I have gone to grok.com. I have gone to the previous chat window where I had asked something about creating a new project, right? And this is what I had asked. Not this one, this one, right? Let me give you some context. I'll be uploading right? I will be asking another question. Forget what has been discussed so far. Start fresh. Let me give you some context. I'll be uploading a CSV file in the project and would need to eventually create a regression model. I could have still written ML, or maybe we'll make it ML, like a regression model on 50 startup data set. And I will be quickly importing few of the basic libraries because I want to have a quick look at the data. Is equals to pd.read csv 50 underscore startups dot csv tf.head. So I'm going to give an initial context. Let's say these are my columns. I'm going to give that dataset with columns da da da. So I need to interact with the word, upload the CSV file and ask questions about it. You need to behave as an ML expert. When creating a new project on Grok, what should be okay? So same question I've asked. Now in the meanwhile, I'm going to create a new project. I'm going to write it down as regression project, 50 startups, and then I'm going to add this as my suggested start a conversation. I'm going to change it because last time we added it and then we changed the prompt while we started interacting with the bot. And the second one is project instructions. So these are my project instructions. I'll again go through it. Project title is this, objective, data set, da, 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 and then data set is clean, instructions for group, correlation analysis, a lot of things it has mentioned. We might not want so many things, model optimization and all. Okay, let it be. Building a multiple linear regression model, building a linear regression model, okay, to predict profit. That's it. Now everything looks good. Attachment, I will try to attach this file, 50 underscore startups. Is this attached? I'm not able to confirm that. 50 underscore startups. Okay, attached. And then start. Okay, I have received and confirmed the uploaded da da da, and then here we have everything is ready. Now, of course, I can give more detailed instructions on what we have done in the previous video to replicate the same in this current video, in this current lecture, but let's try to take directly Grok's output and try to run them. Okay, so I'll delete this piece of code so that we can do everything from scratch. Everything is in one code window. I would like to break it down, and then let's break it down step by step. The second step is loading the file and displaying the basic information about the dataset. We have a no such file error. That's because of the naming convention. Just change it out. You can see the basic dataset information is here, 50 records. The first 5 records looks like this, and the summary statistics looks like this, right? Now, even before moving into the next part, if you also want to get some insights about summary statistics, you can always go back and can you tell me the summary statistics insight in 3 to 4 bullet points, and let's see what it does. So R&D spend and marketing spend shows high variability, with some startups spending nothing, indicating potential outliers or diverse business models. Profit ranges from this to this, suggesting significant variation in startup success. Skewed distributions, the large standard deviations, R&D spend, marketing spend compared to their means, suggest right skewed distribution. So insights can also be, you can easily get insights in case you want to make your notebook even more detailed. You can add these things here, and let's say I'm adding these things here with minute editing. That's it. Now let's move on to the next part, missing values. All good, no missing values. And then going to the next part, so it's visualizing the distribution of numerical features, and here you have different pictures. Right now you can see this is somehow following the normal distribution, but distribution of marketing spend and distribution of R&D spend is skewed, right? So this is something you might interpret. Moving on to the next part, which is correlation analysis. Here you will be able to see that this is how my matrix looks like. Our major focus is profit, right? Because profit is the y variable that we want to predict, and you can see profit has a very high correlation with marketing spend. That's it. Marketing spend and R&D spend. With administration, it has a very low score, very close to zero, which basically means it is not correlated. So if you want to delete this column, it also should not make a lot of difference. Moving on. So next part is checking for multicollinearity using VIF. It's not that mandatory, so I'll try to remove it. That's what I told you, that some prior experience knowledge is also needed. You cannot blindly copy paste all the code. So here it's trying to visualize some of the things like profit by state and then multiple other things. So let's try to run this. So we have New York, California, and Florida. Based on that, we have all these box plots. Similarly, there are few other plots as well, like scatter plot between R&D spend and profit. And it clearly means that there is a increasing trend in all of these states. For Florida, I can see a steady increase. For New York, also steady increase. For California, also steady increase. So the correlation is very high with respect to state for profit, even though it didn't come up in the correlation matrix, because correlation matrix is only plotted on numerical columns. But in case you want to plot this for state, you need to do encoding, right? So you can pause here, and in case you want to do that step of changing the state into encoded values, you can prompt it back, change it to encoded values, right? I'm copy pasting the code. You can see the very immediate step is encoding, right? So df encoded, pf dummy state drop first, right? And then let's say we have this code, and let's say I will try to copy paste the future code as well. But after this, after the dummies, I'll come back to this correlation analysis and try to do that again, because this is what I was talking right now, just couple of seconds back, right? Now let's try to plot this on the encoded one. Wait, encoded. Oh, uh, 1 second. So we, okay, it's because state Florida and state New York is coming as Boolean. That's why it has not a part of my correlation matrix. Let me try to ask. Uh, I know the answer, but I will just try to use ChatGPT. After this, I am getting state Cali, sorry, which one was that? State Florida and state New York as Boolean values. How to convert them to numerical, because I want to plot the heat map. So let's try to see. Of course, we will be having to change the Boolean from Boolean to numeric. So you can see, uh, okay, it has directly taken this piece of code, which should also work. Yeah, yeah, you can see. Now you can see that profit versus state Florida, profit versus state Florida, the correlation is low, and profit with state New York, why it's low? It's a bit weird. It should not be low. Profit with, okay, this was profit with respect to R&D spend, and then as a hue we were using state. So that is the thing. Okay, no problem. No problem. This is what it is. There is no strong correlation. So for profit, the strong correlation is with two things. In fact, three. No, it's two. So R&D spend and marketing spend. Right? Now moving on, and rest of the things I don't want to do it in separate. Oh, we can do it in separate code lines. We have defined the features and then encoded them and then standardized them using standard scalar, and then I am passing the data into the model and running the regression model and doing the prediction. And once the predictions are done, I'm going to evaluate the model. So for evaluation, I'm using some matrices like R2 score, MSE, which is mean squared error and mean absolute error, and then I will try to plot it up in the next line. Now here, for those who might not be able to understand these metrics, whether these are good numbers or not, it's very difficult to say whether these are good numbers or not. You can only identify whether this is good or bad when you compare it with any other regression model, right? And here, if you go ahead and see, here you have the actual profit and the predicted profit, and these are the things, right? So really, the predictions are in the blue dots, and the yellow, the red line is nothing but your um, linear regression predicted line, right? So that is all about regression. In case you have any follow-up questions, you can always ask. Let's say I want to ask, uh, I don't have any other models in mind, so just interpreting the results from linear regression, can you tell me whether these metrics are good or bad? Let's try to ask this, whether these metrics are good or bad. See, R2 score is good, 0.89 R2 score is not bad. Mean squared error and mean absolute error is something that is very difficult to say, right? Because it depends on the scale of the numbers as well. So to interpret the linear regression model's performance, R2 score, this in the context of data set, high R2 score and low MSE. I'll use the summary statistics you shared to provide a clear, concise assessment as an ML expert tailored to your project. R2 score is good, as that's what I told you. What it means, the R2 score indicates 89.87% of the variance in profit is explained by the model's predictor, R&D spend, administration, marketing spend, state Florida and state New York. Is it good? In the context of startup profit prediction, an R2 score of around zero point 0.9 is strong, as it suggests the model captures most of the variability in profit. Mean squared error, as I told you, it's context dependent. See, whatever I'm saying, ChatGPT is also responding the same, right? It's very context specific. Again, mean absolute error also, I would not consider this as good. It's a very context related metric. But yeah, this interpretation has told it is good, so it's good, no problem. Let's say you want to rerun this piece of code with just R&D spend and marketing spend. We can do that as well. I want to rewrite the code only with features R&D spend and marketing spend. Can you remove other X variables and rewrite the code? Because these two are having the highest correlation, others are not. I'm just trying to remove them and see whether we have an improved model performance or not. You can see it has given you the latest code. Let's try to add few lines. Model with just R&D spend and marketing spend, and then I'll run this piece of code. Everything looks good. Reduced this. Okay, I'll just copy paste it because it has not copy pasted it properly, and then run this code. And you can see results are R2 score has improved, right? Now the metrics are, can you tell me this model was better or the previous? Okay, definitely. Okay, I'll not tell my verdict. Let's do a model comparison. I'll try to expand it. The new model results are these, the old model results are these, right? Evaluation, the new model has a higher R2, indicating it explains more of the variance and profit. So model 2 is better. Talking about mean squared error, the new model's lower MSE indicates smaller average squared prediction errors. So model 2 is better, right? And then mean absolute error, the new model's lower MAE indicates predictions are on average closer to actual profit value by almost 492 units. Again, the new model is better. So according to all of these features, all of these metrics, sorry, you can see. So I will write it down as notes here so that you can follow, but I think why it's like this. The new model is better, higher R2 score, lower MSE, lower this. Why it's better? Make it bold. Make it bold. And that's pretty much it, right? So that brings us to an end to this beautiful regression based vibe coding session. Well, in case you have any other use case where you want to get started with, I think you can just replicate the steps that I have done, and I'm pretty much sure you should be able to figure this out. That's it. See you in the next video. Hi. In this video, we shall be focusing on clustering algorithm. Now, we know that machine learning are of multiple types, which is supervised learning, unsupervised, and reinforcement learning. And predictive modeling or predictive analytics is majorly the supervised part, where we will be creating some predictive model to predict something from the future, be it a classification problem or a regression problem. Clustering algorithms basically comes under unsupervised learning technique. And unsupervised learning techniques do not have labeled data. So they are not considered as predictive modeling or predictive analytics or predictive models. However, clustering is also important in the field of machine learning. So let's go ahead and understand what exactly this algorithm is all about. Clustering or cluster analysis is a machine learning technique which groups the unlabeled dataset. That means you have a data set, let's say 10,000 customers. You don't have labels. That means you don't know which of them customer is active, which of them is churned, or which of them is a fraudulent, which of them is a not fraudulent. You just have features like age, salary, location, blah blah blah. You just have customer information. Now, if your manager or somebody asks you to create segments out of it, hey, you have 10,000 records, can you create segments? That means, can you find which customers are likely to be similar to each other? The first question that you ask in these kind of questions is, how many groups do I make? Should we make 4 groups, 5 groups, or 6 groups? There is no certain answer for this. So we go ahead and apply clustering algorithm to find clusters. It can be defined as a way of grouping the data points into different clusters consisting of similar data points. The objects with the possible similarities remain in a group that has less or no similarities with another group. So what are some of the clustering algorithms? The most important algorithm is k-means. We also have mean shift. We also have hierarchical and various other DB scan and various other clustering algorithms. We'll majorly be focusing on k-means when we jump into the practicals part. What are the use cases of clustering? As I told you, customer segmentation, market segmentation, news segmentation, social network analysis, anomaly detection. All these are different examples of applying clustering algorithms. The classic example that we might have talked about, which is fraud detection, that can also be considered as an unsupervised learning problem. What if you get a data set from your manager? It has 1 million records and it does not have labels whether this transaction is a fraud, this is a not fraud, and so on. That means you don't have these labels. If you have labels, then you can simply call your classification problem, divide it into training and test, create models, train the training data, test it on the testing data, do the predictions. So when a new transaction comes in, you will be able to predict. Done. But in clustering, we don't have labels. So what can we do? We have to apply clustering techniques and finalize clusters. Once we get clusters, we probably come to a conclusion that all these data points are similar in nature. We don't know whether these are fraud, or these are fraud. But we kind of get clusters where data points are similar in nature. Now, once you finalize these clusters, you might be asking, fine, we got the clusters, what's next? What is the business utility of these kind of algorithms? Because ultimately, if our goal is to identify them as frauds and not frauds, how can we solve this problem? Now, this is a complex example, but the way we solve this problem is using clustering algorithm. You finalize the clusters and then you take help of domain experts or some cybersecurity experts or your company domain related experts, and experts try to analyze these particular clusters. Let's say one of the clusters is having the lowest records, so people start analyzing from the lowest cluster, so smallest cluster, and using the smallest cluster, using their domain knowledge, they will try to label the data. So once the labeling of data is done, then they move on to the next cluster, then next, and then next. It goes on. But our clustering algorithm is limited to this. It helps you to identify clusters. So that's all about clustering. In the next video, we shall be talking about one of these use cases and we will be solving them using k-means clustering algorithm. Let's try to implement the k-means clustering algorithm. So we have already imported the libraries. We'll try to read the file, and this is the file that I'm using, which is mol.csv. I'll show you the file. That's how the file looks like. I have customer ID, gender, age, annual income, and spending score. Now, for the ease of understanding, as we will be plotting the graph, again, we all know that it is feasible to plot a two-dimensional graph. That means variable 1 versus variable 2. Beyond that, it is very difficult to plot. Three-dimensional graphs, four-dimensional graphs, five-dimensional, and so on are impossible to plot, right? So we will be taking only these two features, and based on these two features, we will be performing the clustering technique. We'll be implementing the clustering algorithm. So I'll quickly take choosing two dimensions for easy plotting. So x equals to df.ilog. Which one? I will only take my third and fourth, which is 0, 1, 2, 3, and 4. That's it. Dot values. Done. In k-means clustering, the most important thing is to identify the optimum k value. And k value is obtained by a technique called as elbow method. Elbow method, where we draw a graph between the number of clusters and the WCSS value in my y-axis. What is WCSS? WCSS means within the cluster sum of squares. Within the cluster sum of squares. Within clusters sum of squares. Now what does this mean? This means if you have a data, something like this. If you are drawing one cluster, then the center point is here. The WCSS is the addition of all these distances, which will be very high, right? When you have one cluster, the WCSS value will be very high. What if instead of this, you have two clusters? Centroids are here. Now the distances are low, right? Definitely the WCSS for two clusters will be low as compared to one cluster. And it goes on. Imagine for each and every point you have a cluster. So WCSS value will almost be 0, right? So WCSS is nothing but within cluster sum of squares, where you have to plot with respect to the number of clusters, and somehow the graph looks like this. Why it is called as an elbow graph? Because the point where it forms an elbow, that becomes the optimum number of clusters. Now in this particular example, I see the optimum value of k is 3. But does that make the k value as 3 prominent? No. We should always do a plus minus activity. So if I am implementing this algorithm, I will do a clustering on k equals to 3, on k equals to 2, k equals to 4, k equals to 5, something like that. So I'll also do some boundary cases. So moving ahead, I will be implementing the elbow method. The code is one time. You have to write down it for one time. No need to memorize. So from sklearn.clusters, import k-means. I will mark my WCSS value as empty cluster. And then I will start with within cluster sum of squares. For I in range of 1, 11, let's say I will do it for 10 clusters. K means equals to k means, n clusters equals to I, init equals to k means plus plus. As I told, no need to memorize all this code. You can simply copy paste these codes whenever you are implementing k-means clustering for a new data set. Dot fit on my x data, and then wcss dot append k-means dot inertia. And once that is done, plt dot plot, plt dot title, elbow method, x label, so my x label will be clusters, my y label will be WCSS. I'll run this, and you can see that's how my elbow method is giving me. This is my WCSS graph. Now where does this graph forms an elbow? You can see somewhere here, this point, it is forming an elbow. So my first guess will be here number of clusters must be 5. This is my initial intake. So what I will do is I will apply k-means algorithm to the data set. So what I will do, k-means equals to k-means n clusters equals to 5. Random state equals to none. Init equals to k-means plus plus. And then y-k-means equals to k-means dot fit predict underscore x. Done. Now last step is to visualize the clusters. plt.scatter y-k-means equals to 0, 0. C equals to red, label equals to cluster 1. So here basically C means color, S means marker size. plt.scatter x of yk means equals to 0, 0, yk means equals to 0, 1, s equals to 100. Yeah, I think should be okay. So I'll copy paste this for 5 clusters, and finally I will do it for my centroids also. Centroids, that means for each cluster what are the centroid locations? 5. I will change all these colors to some random colors: red, blue, green, yellow, anything else, cyan, and black. and just change this to 1 2 3 4. 1 2 3 4. That's it. For centroids, that has to be two things. K means that cluster centers colon 0 and colon 1. Done. And I will copy paste these things from title till show. Cluster of clients. My X label is my annual income and my Y label is pending score. Done. And that's how my graph looks like. And as we are visualizing, okay, X label and Y label. As we are visualizing, just two features, which is pending score and annual income, that is how my graph looks like. And these are the 5 clusters. Now, if you look at this cluster very closely, you can look at this cluster very closely. This piece of group of people are people with low income and low spending score, low income and high spending score, high income and high spending score. So if you are one of the companies or one of the shops from the mall, you have to always focus on these type of customers whose annual income is high and whose spending score is also high. These type of people, annual income is high but spending score is low. These are medium people. So you can prioritize them first, then them, then them, then them, and then them. And that is what your clustering is doing. It is segregating the different types of customers into different clusters. And all these customers are similar to each other within their clusters. Now, the point is, what if I want to plot it for 6 clusters? So I will change it to 6, and instead of 5 clusters, I will just have one more, 6. And let's say purple, make it 5, make it 5. Simple, done. And now I will have 6 clusters instead of 5. And that is what we are getting using k-means clustering. Now, as we all discussed this thing in the theoretical class, that in clustering problems, the output is not certain. We don't know what we are trying to solve. And the end of a clustering algorithm is not an end of creation of a model. Once you have segregated your customers, you can further kind of assign them these labels as cluster 1, cluster 2, cluster 3, and that acts as a class. And for a new customer, you can also predict the cluster, in which cluster the client is falling, and so on. So a lot of things are there also to discuss about clustering, but that's all about clustering that we understood using k-means clustering, how to solve a simple problem. So that's it. See you in the next video. Till then, bye. The next topic of discussion is time series forecasting. Now, time series forecasting is nothing but an extension of a regression problem, but it is not considered as a pure regression problem because of some factors. First of all, it is studied under supervised learning, and of course, the way we create our time series model, it is also considered as a predictive model because it predicts the future, it predicts the next instances. Now, one of the classic examples of time series forecasting could be temperature forecasting or any kind of sales forecasting. Imagine you have a data like this. You have date, sales, and multiple other features. And the date is like 1st Jan, the sales was like to 120 million, 2nd Jan, 3rd Jan, and so on. And let's say you have data till 30th of July and you want to predict for the next 5 days. This is a classic example of time series forecasting problem. Why? Because time plays a vital role here. Time is one of the X variables. So a time series is a series of data points indexed or listed or graphed in time order. And one more criteria of being a time series data is the data points has to be in equal intervals. If your data is like this, 1st Jan and then 3rd Jan and then 11th Jan and then 15th Feb, no, this cannot be considered as a time series data. I mean, there are ways to convert this into time series data. If you accumulate or take an average and consider Jan, Feb, and so on. So you cannot consider it as a daily time series data, but as a monthly time series data, yes, possible. When you are aggregating data into months, you can see the data points are in equal intervals. But the raw data will not be a time series data. And based on the type of data you have, you can also predict your future. Let's say you have daily data and you want to predict for the next 5 days. Possible. If you have monthly data and you want to predict for the next 15 days or 20 days or 30 days, possible. All these things are possible in time series. But time series is simply an extension of regression problem, but the time series algorithms are completely different. The way they work are completely different as compared to regression problems. Most commonly, a time series is a sequence taken at successive equally spaced points in time. Thus, it is a sequence of discrete time data. Some of the examples are heights of ocean tide, counts of sunspots, and the daily closing value of blah 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 industrial average and all those things. Right? I'll give you some classic examples, one of them being temperature prediction, one of them being sales prediction. In your company, you are analyzing what is the CPU utilization of multiple servers. You want to predict what could be the CPU utilization for the next 5 days. That could be an example. Let's say in your server, you are maintaining some file servers, some of the files in your server. So your server is also eating up some file space. You are doing a file space utilization prediction. All those things comes under your time series forecasting. You are running a newspaper agency. Daily, the number of newspapers that are sold from your agencies are like 250k, 300k, 320k, and so on. And you want to predict for the next 5 days, 10 days, or 1 month. That can also be a time series forecasting problem. That's all about time series forecasting problem. In the next video, we shall be seeing a small Python code on how time series forecasting problems work. Let's implement time series forecasting using one of the time series forecasting algorithms. We all know time series forecasting algorithms are very similar to regression problems because they are nothing but an extension of regression problem because they do a prediction on continuous variable. But one of the most important feature, one of the most important aspect of a time series data is date. Date feature is very important. So in this particular exercise, we will be using one of the data sets, which is air passengers data, which talks about in which month, how many passengers were there. And let's say you have data from 1949 till 1960, which will be used in your model. And you will be able to predict for 1961 or probably 1962, 62, and so on. This is what the use case is all about. So there are multiple algorithms in time series forecasting which starts with ARIMA. ARIMA is auto-regressive integrated moving average model. Internally, there are multiple flavors of ARIMA which is AR, MA, ARMA, ARIMA, seasonal ARIMA, seasonal ARIMAX, and so on. Multiple other sub flavors of this algorithm. Another algorithm is LSTM, which is long short term memory, which is nothing but one of the extension of recurrent neural networks, which is again an advanced machine learning topic which comes under deep learning. Another one is Facebook Prophet. Facebook Prophet is one of the algorithms, obviously by the Facebook team, where they made this algorithm open sourced probably in 2017 or 2018. And since then, it has been one of the top performing algorithms. There are multiple other algorithms like Holtz Winter and various other algorithms like Garch, some advanced algorithms like NBits, and so on. So in this particular exercise, we will be using Facebook Prophet to read a data and then do a out of the box forecasting for the next 6 months, 10 months, 12 months, or 5 years. Okay, so let's go ahead and implement the Facebook Prophet algorithm. So I've already imported all these libraries. My data set, I have locally uploaded it, so I'm using directly from here. That's how my data set looks like. I have month from 1949 January, let's say we have till 1960 December. So we have data from 1949 till 1960, almost 10, 12 years of data. And using this 12 years of data, let's say we will be doing a forecasting for next 5 years. Okay. So I have renamed all these columns because that is how Facebook Prophet requires. Facebook Prophet requires you to rename your date column to DS and your Y variable to Y. So I'll do this and I'll do .info, which basically talks about this. You can see my DS is nothing but a date object, but here it is mentioned as object. So I will convert it into date time. So I'll do this. Once this is done, very simple, I'm just calling my Prophet model equals to Prophet, and I'm fitting my data frame. Here there is no concept of training and test. If you want, you can also divide this data, let's say till 1958, you keep it as training data, then call your Facebook Prophet, and then do a prediction for the next 2 years. And then on these predictions, you compare and check your results. That is possible. But what we are doing is we directly feeding the 12 years data to a model so that the model understands everything, and directly we will ask the model to do a forecasting of 5 years. How do we validate whether this model is performing good or not? That is a questionable thing here. It is difficult to validate. If you are directly passing entire data set to your model and predicting, it is difficult to validate, or you have to wait for 1 year to validate. Obviously, this is a better technique in case you are trying to validate your model. But imagine your model is already validated. In that case, you can directly pass the entire data to the model and predict for the future. So I've already run this code, model.fit. Here I'm calling the model.make future data frame. How many periods I'm passing? I'm passing 60 periods. Frequency equals to M, basically means month. So there are multiple other frequencies like M, D is day, year, week, and so on. So if you want to do a frequency of frequency of year and 60, that means it will be predicting for 60 years. So till 2020 it will predict 2021. And if you pass M and 60, it will do it for next 5 years, which is from 1961 till 1965. So I'll run this, and then I will pass my future to my model.predict and save it in the forecast. And then I'm plotting my forecast, and that is how my forecast looks like. So till here, till 1960 is my original data, 1960 December, and this is my forecasting. And obviously, as this is a very predictable data, I can easily predict that obviously the trend is high. There is an increasing trend, and there is a seasonality as well. Like every year at certain point of time, there is a spike. So it is quite predicted that it will be something like this, and the model has also done a good job. Another method inside Facebook profit model is plot components, which basically talks about the different components of time series. You can see an increasing trend. You can see some yearly seasonality also. And that brings to an end to our time series forecasting. As this was one of the simplest algorithms, I choose this. In case you want to implement other algorithms, you have to explore by yourself. That brings to an end to a predictive model module. So I hope you enjoyed the predictive model building, especially clustering, especially the classification, regression, and time series forecasting, which are basically considered as a predictive model. Clustering algorithms, however, are not considered as predictive models, but well and good in case you want to learn all these things you have already learned. That's all about this module on predictive modeling. See you in the next video. Hi, welcome back. In this video, we shall be implementing a time series forecasting algorithm using vibe coding, using AI tools. So the dataset that we are going to use is air passengers dataset. Let me quickly read it on Google Colab and rename it. And here we are. Our dataset is ready. Let's try to do a quick importing of the basic libraries. Import pandas as pd, numpy as np, import matplotlib.pyplot as plt, and then df is equals to df is equals to pd dot read csv air passengers dot csv and df dot head 5. Okay, so this is how my data looks like. Let's go to Copilot and start working on this particular project. So for this exercise, I'm going to use one of the algorithms. We can go for Facebook profit. So let's go ahead and ask. So I'm not showing you the, okay, let's try to quickly upload, sorry, not new, upload air passengers file, and then quickly tell that you want to implement act as a time series expert and using Facebook profit, can you prepare a time series model that is trained on 80% of this data and rest 20% can be used as testing purpose. Do this. I think this is fine. Let's try to ask and see how are we getting the results. Absolutely, let's walk through how to set up a time series forecasting model using Facebook profit with the 80-20 training test split, right? The very first thing is loading and preparing the data. I'm just deleting this. I will be following exactly from this Copilot, right? So let's try to use this and let us write it down as step 1. I will move it up. Step 1, load and prepare the data. And here I am loading it. That's it. And the second step is splitting the data 80% training and 20% testing, right? So split index, and then I'm dividing the data into training and test, right? Then I'm fitting the profit model, from profit, import profit, model equals to profit, model dot fit train. In case in your case, if it is not working, you just have to install PyStan and then install profit. If you encounter any kind of issues, ask Copilot directly, you will be able to get the results. The step number 4 is forecasting the future, same length as test, right? Because test is up to 20% of the records, so we will be using the same forecasting technique for those many records, so that you can compare those results, right? And then visualizing the forecast. Personally, I am using Microsoft Copilot on a very rare basis, but this is how it is. You can see this part is your prediction part, right? So it has already done a good prediction. Going back, step 6 is evaluating your model, where it will tell whether the model has done a good job or not using multiple metrics. Now here is the catch: in regression, like in classification, even if you're running one model, you can still identify whether these models results are good or not by comparing the metrics, right? You have recall precision, F1 score, accuracy score, but in regression you still have metrics like ME, MAE, MSE, RMSE, but the values can vary a lot, right? So unless you run multiple models, you will not be able to judge whether this model has done well or not, right? But even though we have evaluated the model, we have got MAA as 33 and RMSE as 41. Now here, let's say I want to do a more 5 records prediction and plot them with the data frame. So I'm just extending like 5 additional future predictions. So I will try to extend the forecast by 5 periods. Copy this and then appending the forecast to the original data, and then copy this, and here we are plotting it all together. Trust me, when I started working on Facebook Profit, I created the very first model after a lot of hassle. There were installation issues, there were so many issues, I cannot really talk about that. But right now, with the help of GPT, oh, this is the time series graph, and the red one is the forecasted. So it has not done the plotting at the right part. Uh, okay, combined. Let's try to check what combined is. 1958. Okay, let's try to see df.tail. Yeah, that is the problem. So what it has done is it has taken 5 steps from the testing data, right? That is why testing data was still how much was still 1958 or something. So what we need to do is, let's go back to the code, and I'll be able to identify the problem. So we have the training data here, then we have model profit, and then forecast into the future, and then we have evaluation, forecast, future extended. What is this future extended? Ah, okay, this is the problem. Future extended is model. Okay, the model is trained on training data, right? That's why. So what we need to do is we need to change here directly, right? um, okay, let's go back. Let's say we want to extend this forecast by 4 periods. So what we need to do is, first we need to do model.fit on the entire data, right? Not only the training data. And then model.fit the entire df. Then I can go ahead and do the other things. Profit object can only be fit once. Okay, no problem. Let's try to create a new model. Model 2 fit on data frame. That's it. And then model 2. That's it. Future extended. Yes, now you have 1961 data. Now you are applying the forecast to the original data. Now you have the new combined. Now you are plotting it all together, and now you have the results. You can see the results are not bad, right? Because eventually, if you take this to the next level, it would eventually look like this, right? If I have to plot it, right, it is something like this, right? It is following this pattern, right? Here, and then let's say I'll do it in green. It would have been here, and then it would have been something like this, and then something like this, and then it would have been, sorry, it would have been something like this, and then something like this, and then something like this, right? So I would say it's not bad. Maybe what I can do is I can have more predictions. Let's say we'll try to do like a 15 predictions. Make future predictions, plot 20. Let's say we'll do 20. Let's say we'll do 1 year. Okay, 1 year. Okay. The reason it's not taking is the tail 20. Ah, why it's taking from 8? That's why it is doing a prediction for after a little bit of gap. Let's see. Frequency is month. TF dot tail 5 is 1960 December. Let's say I'm just creating the model. I'm extending. I'm doing a tail of 15. 1 2 3 1 2 3 4 5 6 7 8 9 10 11 12. Okay, I understand what's happening, but I think this is better. And now if we do this and do this and do this, no, it's still not coming properly. Okay, let's do one thing. As we are doing vibe coding, let's move back to Copilot and give our prompt. I want to do a 12-step future prediction and train the model with the entire DF. Can you rewrite the code? Okay, so I will try to delete it from here and evaluate the model was fine. From here I will try to make it 12 periods, and from here I will start deleting it. Okay, and I will rewrite this code. We have everything. I'm just creating another model profit, and then forecasting for the next 12 months, and then visualizing the next 12 months and view the final 12 predictions. And you can see these are the 12 next predictions, right? And if you want to check the last 12 records, here we have the last 12 records, right? So this is how we can do the predictions. If you want to do out of sample forecasting for next 10 years or 10 days or 10 weeks, I think you know that we need to change the frequency, or directly go here and tell that I want to do a next 5-year predictions, but keep periods equals to 5 and change the frequency and rewrite the code, and it will be able to give you the latest code, right? So you can see everything is fine, but here it has just changed the frequency to year start, right? And then everything is same, right? Just if you want to rerun this code, we can also rerun predictions for next 5 years. We will run this, and then we will run this, then we will run this, and then we will not need it. And you can see, yes, as this is a huge prediction, see the data is monthly data. When you are doing a prediction on yearly data, it is somehow taking the aggregated values. It is able to identify the linear trend, but the results are not up to the mark, right? So if you change it to, instead of 5 years, make it 60 months, which is also 5 years, right? But make it ms and rerun this. We will do it in the next piece of code. Let's say we change it here to ms and make it 60, and here you go, better results, right? But the same thing, you are still doing a 60 months or 5 years is same, right? You are doing the same thing, you are doing a prediction for the next 5 years, but here you are doing on monthly level, but here you are doing on yearly level. That's why you can see aggregated values. That is the difference, right? So it is always recommended to do the predictions in the same interval as the original data is, but yeah, there are options. If you want to change it, you can change it, but the results will not be great, it will be aggregated, right? So that brings us to an end to this vibe coding session on time series data. And the way we have explored Microsoft Copilot without signing in, you can see sign in is not mandatory. If you sign in, it's always good. If you are working on private data for your company, never ever post it online on public forums, on public chat GPT, or on public Copilot. Always make sure you are signed in, and make sure do not upload any kind of very confidential data as well. So in my case, what I do is, if the data is not confidential, uh, sign in is mandatory. I never upload it publicly, even if I'm working on my YouTube projects or my Udemy projects. I never upload anything publicly. Now this was just a basic air passengers data which is publicly available, so I used it without signing in. I usually sign in and do everything. Whenever it is confidential data, I don't even use these tools. I have already created a tool which is very similar to ChatGPT or Grok, which is on my local machine, and it is also deployed on AWS EC2 instance. So whenever I have to use, I can use that. Well, I cannot show you that, but to build such models, of course you need to have some more knowledge, but you can also take help of ChatGPT to build such kind of a tool. You just have to use OpenAI APIs and create something. Well, that is something which is taught in the data science and AI program as well. Well, so that's all about this particular session. I hope you enjoyed it. See you in the next video.